Here. Is that any better? Can you hear me now? It sounds like the volume rocker may have gotten turned around a bit. Thank you, Danny. Hi. Oh, we're back. Okay, good, good. All right. Is it too loud? Too quiet? I've got a little volume rocker on here, and that must have gotten turned. It's good now. Is it too loud? Is it too quiet?
Ontogeny.
I know we had it perfect before. It's perfect. Thank you. Excellent. Well, let's try this again. Take two. Welcome to Paleontologizing. It's good to have you here. My name is Danny Anduza. I'm a dinosaur paleontologist. As you probably know already, a paleontologist is a fossil scientist. Paleontologists work on all kinds of different fossils, the preserved remains of ancient living things. I work on dinosaurs in particular. And that's most of what we've been finding out here in the Almond Formation of western Wyoming. But here we've got a site with more than just dinosaurs. In fact, dinosaurs are just a small part of this site called Turtle Hill. As the name implies, we've got turtles. We've also got tons of beautiful fossil leaves, which I'm really excited to show you. We've got some freshwater clams. We've got freshwater fishes. And we've got a few bits and pieces of dinosaur bone here and there as well. So this is a really cool site, and I'm glad you're here. The whole point of these broadcasts is to be able to show you how paleontologists do our work, you know? It's one thing to tell you about it. It's another thing to show you. So, if you've got any questions at all, do not hesitate to ask. Yeah. Anywho, yeah. And back to Turtle Hill. Yes, indeed, Cast the Dreamer. How are you? I didn't stream from this site last year. So, yeah. And it looked completely different last year. We've got 3 of the crew members from Cincinnati up there. And then one of our new crew members from from Utah as well. So we're going to go say hello to them in just a minute. But how's everybody doing? And we got a hype train incoming? Beautiful. Thank you for the support. And weren't some of the inland seaway fishes huge? Wheel 6'2"? Some of them, yeah, but these are not from the seaway. These are, like, from when this was a terrestrial environment. This is from, you know, like an ancient lake. And, yeah, some of these are huge. Does anybody here know what a bowfin fish is? We still have them here in North America. They're really, really cool fishes. They're, you might say, primitive fishes, non-teleost fishes, but they are super cool. And today's bowfins get to up to maybe a meter long, which is big for a freshwater fish. These ones are like maybe up to 3 meters. We've got remains of a huge bowfin here. Big, big, big fish. And we keep finding more and more pieces of it. And if you're lucky, there might be some up there that I can show you. And what's that bird singing in the background? I heard a rock wren earlier. That's probably what that is. Kind of sounds like, we used to call them laser birds. That's probably what that is. Yeah. No sign of crocodilomorphs? I'm not sure if we've got any croc scutes or anything. I can go ask Alexander Morrison. But, glad you're here. Welcome. And how do you know where to find fossils? This is the most common question I get out here. You got to find areas with the right age rocks that are exposed on the surface. So in places like this, like western Wyoming, this is what we call like a high desert environment. Where, yeah, you've just got lots of exposed rock on the surface because it's too dry for too much plant cover. In fact, this is much more lush than I've ever seen it out here. You know, these kind of low scrubby plants like this, they are happier than they've been in a long time. And we must have gotten a lot of rain there. Oh, and who is this? Got a little sparrow there. Is that like a song sparrow? Who are you? Who are you, little sparrow? No, upright tail. That might be a kind of wren? It's not a rock wren, I don't think. Who are you? Who are you? You're beautiful. We've got our best bird sighting yet for Thursday Birds Day. Excellent. Well, well, well. Very cool. Oop. Running over there. Very spirited little bird. Nice. Where you going, bird friend? See? Not all the dinosaurs out here are fossilized. Some of them are still flitting around. Right there. Very cool. You do your job. Get those bugs. It is, for once, not windy today, but it is really hot. And so the bugs are just kind of going nuts out here. I keep getting flies and wasps coming up to me. So hopefully these birds can help cut down on that a little bit. Yeah. Anywho, yeah. You thought that was a song sparrow, Miss Yvette? Might be. Although the tail seems really long and like... Yeah. Cheep, cheep, cheep. Get closer. Very energetic little bird. Will not stay still. I don't know who you are. Could be a fox sparrow? Who are you? Why? Yeah. Nice. Very cool. Very cool. Anyway, yeah. We've got some neat wildlife around here, too. Still around, still living. But anyway, we're at the Turtle Hill site, and I'm going to show you around in a minute. And let's see here. Yeah, and sorry you can't see it thing. It's, this is like a wide-angle lens, and it doesn't zoom at all. It's static, which is what you want in a place like this, but it does make it tougher to zoom in on things like birds. Oh, over there. Let's see if we can get a little closer. This is probably a fall.
Ontogeny.
Let's see. Right there. Hey there, little bird. Get those bugs. Get them. Get them. Yeah. I wonder if there's a nest around here. Wow, you're pretty. You're very pretty. Any glimpses of the bird? Can you see it at all? Right there? I'm not used to seeing people out here. Nice. Anywho, and 84 degrees. It is hotter than that here. I used my portable thermometer, the little digital one that chap bought me last year, and it said 93. So it's warm today. It is warm. Yeah, anywho, let's go ahead and go take a look. It is Thursday Birds Day. That's why we're, paying such close attention to the birds here. Let me walk here on the side a little bit. So the guys have ingeniously created a shade tarp for themselves with some shovels and then one of the vinyl tarps that we have here. So it's really making things a lot more comfortable than it otherwise would be. But yeah, welcome everybody to Turtle Hill. This is actually a really prolific site, as you will see. Important stuff coming out of here. And I'll tell you, Quinn was a little bit jealous this morning. He didn't get to come out here. He's like, Danny, you're so lucky you get to just bounce around to these different sites and, and stream them. He's like, I want to go to Turtle Hill. He helped me carry some of the gear over just a little while ago, and he was really impressed. This looked completely different last summer. Didn't have these terraces like this. It was just kind of a gentle hill with scrub brush on it. And yeah, now it looks like this. Awesome. And we'll see the plants. You will, look, Max, absolutely. I really hope On the Diagonal is here today, because we are going to be looking at some really cool fossil plants, some of which, might be new to science. Should be really exciting. And Will62 says, so basically there are fossil fragments literally under your feet as you walk? Absolutely, yeah. Yeah, that's why this is such a cool place. Let's go take a look at the site up here. Got Jesse using the whisk broom there, clearing off some of that dust so we can see the rock surface. Now he's been hard at work over here with the, we call it a McLeod tool. It's like what firefighters use for like clearing trails and stuff like that, and digging trenches in order to prevent fire from spreading. It's really useful for work out here too. And we've got all this kind of blocky sandstone like this all through here, and then also we've got these nice coal beds. So this is what's left of probably like an ancient swamp, that kind of environment. So this coal is really organic rich, and I bet you if we were to take this back to camp and put it in a campfire ring, you know, it might burn pretty well. I'm not sure how high quality this is as coal, but you know, it's very recognizable as coal to a paleontologist. You brought some back and burned it?
Eric did, and it burns pretty quick.
Pretty quick? Nice. Yeah. Cool. Yeah, some of you might remember Jesse, I think, from previous streams. Jesse from Utah. It's your first summer out here digging, right?
Yes, it is.
Nice. Jesse's been great, so we're lucky to have him. But look, as he's clearing away some of this, get down to some of that more organic-y stuff. When I say organic-y, I mean it's like it's got organic material in it. It's got the remains of ancient plants all compressed. It's very carbon rich. Yeah. Yeah, and then up here, we've got some plants. Let's take a look at those. Yeah. Oh, chat's saying hi to you, Jesse.
Cool or interesting?
Yeah. Parkalua says keep some for prehistoric s'mores. We don't have marshmallows out here. It might have been an oversight. But here are a bunch of sandstone slabs that the guys have brought up here because they contain fossils. So this whole like pavement of sandstone here, these are all placed here by the guys because there's sometimes some gorgeous fossil leaves and stuff in here. Let's take a look and I'll show you some. Let's see. Ooh, right there. Take a look at this beautiful fossil leaf right there. You can still see the veins. I'm not an expert in plants, either extinct or extant. So I can try to identify some of these, but yeah, it's not going to be the greatest. I'm not a plant guy. But yeah. Anyway, look at this right here. 73 million years old, and you've still got that kind of preservation. This is gorgeous stuff, and really important scientifically. If we want to know what this ancient environment was like, you gotta look at the plants. The plants tell you what the climate was like, how much moisture there was, you know. These plants are related to modern plants, you know. By the late Cretaceous, you've already got the evolution of angiosperms. Flowering plants are already starting to take over. You've got things like dogwoods and laurels, both of which we'll see here. And yeah, you can do things like look at the shapes of the leaves, because the shapes of the leaves actually give you a clue as to like what the temperatures were like in that environment. Different kinds of plants prefer different temperatures and different latitudes. So the plants are a wonderful, wonderful kind of window into what this environment was like, what the average temperatures might have been, how much rainfall you would have, the amount of moisture in the that kind of thing, you know. Yeah. So yeah. Better Place to Be says super cool. Thank you. Yeah, and those aren't even the prettiest ones. We'll find some more charismatic pieces here and there.
The ones the pile behind you.
Thank you, Jesse. Nice. Jesse says these are the really nice ones over here. Yeah, look at that. Hoo 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 hoo. Gorgeous. Yeah. That almost reminds me of broadleaf tree, like a sycamore or something, maybe. If I'm thinking of the right kind of plant, I don't know. We need to get diagonal here in the chat. Yeah. Yeah, pretty cool, right? Let's see, what make and model is that watch? Oh, this isn't a watch. This is a phone. There's you, chat. Yeah. This is a Google Pixel 7. Oh, that's a fossil watch. I don't know what it's called, but it's a fossil watch. Had that for a long time. Anyway, we're not here to talk about watches. We're here to talk about fossils. Well, you know what I mean. Yeah, take a look at that. Right here on the slab. Gorgeous, gorgeous. You can still see those veins like that. Absolutely beautiful. And it's not just pretty, it's also extremely informative scientifically. Ethan was saying that Kirk Johnson from the Smithsonian, kind of a big head honcho there in paleontology in Washington, D.C., he's really interested in these plants and might want to publish on some of them. So we're pretty excited about that. Yeah, but they are gorgeous. And as you can see, we've got part and counterpart right here. So this slab was like this, and then there you go, part and counterpart. Very nice. Little pieces crumbling off. We might be taking some of these back to camp later. But yeah. And Luca Grabakar says, "Yay, how are you doing, Luca? Welcome." And Dropped a Fish says, "This showed up in my suggested." And I was like, let me check it out. Well, welcome to Paleontologizing. Again, for anybody who's just joining us, my name is Danny Anduza. I'm a dinosaur paleontologist, and out here in Wyoming with a really cool crew of people digging up dinosaurs and any other important fossils that we can find. Anything that's scientifically interesting, we are collecting. And all these fossils are going to the Cincinnati Museum, where they can be held in the public trust in perpetuity and enjoyed by the general public. So if any of you live in Ohio, make sure you check out that museum in Cincinnati. Hopefully in a few years some of these things are going to be on display. Look at those leaves right there. Very, very nice. Yeah, excellent. Yeah. Beautiful. Yeah. And Allure, thank you for the Prime sub. I really appreciate that. Thanks for your support. That's what makes all this possible. Thank you for that. Yeah. And there's Jesse depositing some more right there. Nice. So we got quite the operation going here, I gotta say. I'm really impressed with the number of cool plants that we have here. And love this channel. Had to subscribe. Thank you, Allure. Appreciate it. Yeah. And Will62, thank you for the gift sub. Appreciate that as well. Now take a look. We've got some fossil clams right here. Gastropods. In fact, here's a little fossil snail. Look at that. This is such a cool site. There's so many cool things coming out of this. So, fossil snail right there. Fossil bivalves. I've been told that these are unionid clams, which is, maybe that's kind of a wastebasket group, but lots of stuff gets thrown under that label, unionid. But yeah, these are like freshwater clams. And their presence here kind of tells us something about what this ancient environment was like. Yeah. So take a look at that. Just beautiful. Really, really nice. 73 million years old. Yeah. Pretty awesome. Pretty awesome. Yeah, and how old would you give a rough estimate for these fossils? About 73 million years old. So we're digging here in the Late Cretaceous Almond Formation. So this is about 10 million years, maybe 12 million years older than dinosaurs like T-Rex or Triceratops, So we're here 13 million years before the big extinction event at the end of the Cretaceous. So it's an important time. Dinosaurs are absolutely thriving in this environment. You've got all kinds of other critters around here too. And, I'm particularly interested in the dinosaurs because that's what I study and what I publish on. But you can't really understand the dinosaurs in a vacuum. You have to understand the environment that they're living in as well. That's what this site is all about. Turtle Hill here is honestly a world-class site for all these different late Campanian critters, about 73 million years old, from the late Campanian stage of the Late Cretaceous period. This is, for what it is, it's probably our most scientifically important site here, because we've got so many different critters, so many different organisms. It's like a beautiful kind of sample platter of the animals that we're living in this environment, animals and plants. Important stuff. Yeah. Anyway. And how do you find these fossil-rich sites, T. Schroeder? I really need a command for that. You can use command prospecting, ! Prospecting, for some clues about that. But, we've known that there were fossils here since about the 1930s. Barnum Brown, famous dinosaur paleontologist, he's the guy who discovered T-Rex. He came and collected here in 1937. But he didn't actually name any of the dinosaurs that he collected, and he didn't even dig up all the ones that he found. We think that we've relocated at least one site that Barnum Brown was previously working, and he just didn't dig anything up out of it. But anyway, we know that this is a fossil-rich site because fossils have been found here before. But the way that you figure out that an area is the right time and the right place to, find critters like dinosaurs is that, well, basically, you got to figure out. Here, let's go back for a minute. Let me start this over. Say you're interested in a dinosaur like, let's say Dilophosaurus. Like from Jurassic Park. Say you really want to find some more Dilophosaurus fossils for, your graduate thesis or something like that. Or your museum really needs a Dilophosaurus for whatever reason. We know that Dilophosaurus lived about 193 million years ago. So you got to find rocks from that particular time. And in order to do that, you look at your geological maps. Most of the rocks on planet Earth have been mapped out. We know how old most of the rocks are. And so you consult your geological maps and you figure out where in the world rocks of that particular age exist. And once you've got that, you can narrow it down further by looking at things like satellite images, Google Earth, stuff like that. In order to figure out where on Earth that age of rock, like within the parameters that you already got, the rocks are here, but where in that area are the rocks actually exposed on the surface? Where can you go out and look and just find rocks like this exposed, not underneath a prairie or a parking lot or a forest, but just beautiful exposed rock on the surface? You have like satellite images and stuff that you can use to determine that. And then once you have that, you can kind of get a better sense of where to look. And then you have to figure out land ownership. Where do I actually have permission to dig? You either dig on public lands, like Bureau of Land Management, federal land, and you get permits to do that. Or I guess you could try and dig on private land, but then you need the express permission of the landowner in order to do that. And then you just go out and you start exploring. You do what we call prospecting. You walk along and you look at the ground for anything that looks particularly interesting. You do a lot of this, picking stuff up, turning it over, and going, oh, that's not bone. That kind of thing. So if you're looking for Dilophosaurus fossils, you're going to look for anything that looks like bone. And then once you identify little bits of bone, you try and follow them up to the source. Because maybe they're eroding out of the side of a hill, maybe there's a skeleton in there. And so you kind of follow the bone trail up to the source, and if you're really lucky, you find a skeleton. It's basically, I'm oversimplifying a little bit, but, that's how we find these sites in the first place. Yeah, let me see if there's any other questions here. Yeah. And yeah, I can't tell you exactly where we are here, except that we're near Green River, Wyoming, because, you don't want poachers and people like that coming in and taking our fossils. That sky gets me every time. Gorgeous landscape. Isn't it nice, Invisible Dimensions? Yeah. And you're welcome, T. Schroeder. Thank you for the question. Yeah. But yeah. And where's Takuya from? He's from... Oh, what island? I think it said Shikoku in Japan. Hokkaido, Honshu, Kyushu, Shikoku. I think he's from the only one that doesn't have bullet train service, he said. I think that's Shikoku. But he's been in the US and in Canada for a long time. He's one of the world authorities on mosasaurs, actually. There was that mosasaur that was just published last December, I think. The one with the dorsal fin. That was Takuya. That was his work. Yeah. It's funny, somebody was asking him about that, and one of our new volunteers was asking Takuya, like, oh, did you work on mosasaurs? Did you hear about that one that may have had a dorsal fin? Like, what do you think about that? Do you think they got that right? And he's like, yeah, I think I got that right. That's what he said. He was great. Yeah, Takuya is awesome. He's over at the Barnum Brown Hadrosaur site today, the one with the bucket. The Dell site is what we call it. Yeah. And how long are you staying out on the site? So here, about another 3.5 hours for today. But I'm only at this site probably for today. I'm bouncing around to different sites on each day, helping out where I can, and then I want to be able to go to different sites so I can show you the full breadth of what we're working on here. So rather than just staying at one site and kind of focusing on it like most of our crew members are doing at different sites, I'm kind of bouncing around a whole bunch, kind of like Ethan is, our expedition lead. This morning I was over at the Ceratopsian site helping out with overburden and stuff, but I haven't really helped out here much. I just got here a little while ago after lunch, and just here to show you around. Yeah, but I'll be out here in Wyoming doing field work until the end of June. June 30th is our last day. So, yeah, pretty excited about that. I'll be streaming every day that I can, every day that is reasonable. So we're gonna have close to a month's worth of streams out here, and I'm stoked for it. Got another 24 days? Yeah. And Jody Fish. Oh, thank you, Golganek, from Jody Fish. Sorry, which university? So, is it Cincinnati University that Takuya is at? He teaches there. Yeah. Anywho, yeah. And Nubo says, what could the fossil plants reveal to us? Oh man, what can't they reveal to us? Here, let's take a look. Let's find a particularly pretty one here to pour over. Let's see. Here we go. These are gorgeous. Yeah, take a look at these right here. They almost look like laurel leaves. In fact, they might be laurels. Yeah. And so a lot of these fossil plants have modern relatives. And so by studying the fossil plants and comparing them to their modern relatives, we can get a good sense for what this climate was like, you know? For instance, up in like the North Slope of Alaska, they have fossil plants from the Eocene, things like palm fronds and stuff. Very warm weather plants that demonstrate that back during the Eocene, that area was tropical. You had tropical plants up in northern Alaska at the time. You know, climate is a huge part of what plants can tell us about. Climate, you know, which includes average temperatures and includes, you know, your kind of average precipitation, stuff like that. And sometimes we find fossil plants where they don't really have super close modern relatives, but you can still tell things about the environment using those plants by looking at things like the number of pores that you see on them. That has something to do with temperature and climate. Like there's a correlation between warmth and the number of pores. Excuse me. And the morphology of the plants as well, like whether or not they have a drip tip. So a lot of tropical plants that are in very rainfall-heavy environments, they've got a beautiful, like, pointy tip at the end of the leaves, and that's in order to help water run off of them. So you don't have water building up and then, like, damaging the leaf, weighing it down. So stuff like that, really, really important. Plants are an excellent proxy for ancient climate, if that makes sense. Tells us what this environment looked like. Yeah. So this is maybe our most scientifically important site here, Turtle Hill, because of all of the cool little microvertebrates and invertebrates and the plants. Holy cow, the plants are super important. Yeah. And Diagonal, I am so glad you're here. Welcome, welcome, Diagonal. We are... Some of these plants are going to be new to science. Here in the Late Cretaceous Almond Formation. Diagonal, tell me. I want to say laurel when I see this. What do you think? Am I way off base there? To me, this reminds me of a laurel. Because I think I remember what a laurel looks like, and I think I remember it looks like this. But, you tell me. Yeah. Oh, and we got a raid going here. Well, well, well. Welcome, welcome, raiders. It is good to have you here. From Dapper Dame. Hello, hello, raiders. Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here in western Wyoming, digging up dinosaurs and other fossils, and showing you how that all works. This is the best way that I know of how to do science outreach, and I'm glad you can be here for it. Thanks for joining us. Thank you for the raid, Dapper Dame. How was your stream? I hope it was really good. Yeah. Without seeing the veins, I wouldn't want to say there's a lot of convergent evolution in leaf outlines, but laurels are a possibility. Nice. Thank you, Diagonal. Cool. Apparently we also have things like dogwoods and maybe sycamores from here, magnolias, and we've got some conifers, possibly some metasequoia, which is really exciting as well. And I think we might have some of that metasequoia type stuff over here. It's already been laid out. So everything that you see down here was carried up by the crew from down here, down in like the quarry area. So yeah, lots and lots of really cool stuff coming out of this big kind of blocky sandstone here. Really consolidated material. Perfect kind of spot to find some plants. Fine plants we have. Yeah. Look, Max says, would you say plants evolved significantly since that era or remain similar? It's a tough one to answer because it's both. During the Cretaceous, we didn't have a lot of our most common plants yet that we have today. Flowering plants had just evolved in the early Cretaceous period, and they're kind of starting to take over by the late Cretaceous, but we still don't have things like grasses. There were no grasslands when dinosaurs were walking around. So imagine a world without grasses, basically. And prior to the early Cretaceous, you go back to the Jurassic period, no flowers. A world without flowers and without grasses. Yeah, no flowering plants. The angiosperms are the group of plants that, you name a plant and chances are it's going to be an angiosperm. That whole group didn't even evolve until the early Cretaceous period. So instead, you had what we call gymnosperms and other plants like that. You had conifers, like pine trees, redwoods, stuff like that. You had ferns, you had cycads, horsetails and club mosses and spike mosses. But stuff like this, the sagebrush, this is a flowering plant, as I understand it. This is an angiosperm. These guys did not exist during the Cretaceous period. They had not evolved yet. Yeah. But yeah. And yeah, fern friends, lots and lots of ferns, rave turned, absolutely. Wombat Hole says big mushrooms? Not that I know of, no. I think that was long prior to the dinosaurs, long before the dinosaurs evolved, back in the Paleozoic. Maybe you had large mushrooms, like giant mushrooms, but I don't even know that for certain. Yeah. But yeah. And lots of ginkgo and conifers. Absolutely, Mommy does. How could I forget ginkgo? There were so many different kinds of ginkgo back then. It was a really diverse group. Now there's only, what, one species? Ginkgo biloba? Ginkgo biloba? But there were many, many different kinds of ginkgo during the Mesozoic when dinosaurs were running around. Yeah. But yeah, were there any mean plants back then, prickly or poisonous? Probably, aught for naught, but that's kind of hard to say. Yeah. Yeah, there almost certainly would have been, but I don't know enough about fossil plants to give you a definitive answer about that. Sorry. One of the most common things that a scientist will say is, I don't know. And that's an exciting phrase because that means there's still opportunity to find out, you know? Because if you look into it and it turns out nobody knows, then wow, there's a discovery waiting to be made there. So that's honestly a huge part of science, is being able to say, I don't know, and then trying to follow that into making some cool discoveries. Anywho. I've been enjoying the dig. It says Tim the Sorcerer the Third. Thank you. Appreciate the kind words. Where do you take your findings after the dig? So all of these fossils are going to the Cincinnati Museum Center, or the museum in Cincinnati, the one at Union Station, Union Terminal, which is an incredible museum that unfortunately I've not been to yet. But they're going to be holding these fossils in perpetuity there in the public trust, so that future scientists will be able to study these long after I'm dead. And, yeah, and the public will be able to enjoy the ones that get put on display as well. So, yeah. We're not out here doing this for fortune and glory. That's not why we do what we do. This is for the benefit of science and for the advancement of human knowledge. And Carl Sagan quote... There are naive questions, tedious questions, ill-phrased questions, questions put after inadequate self-criticism, but every question is a cry to understand the world. There's no such thing as a dumb question. I like that, yeah. Yeah, I think Carl Sagan and I would be in agreement about that. Or I would be in agreement with him. He said it. So, yeah. 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 Man, there's a really cool grasshopper I just saw over there, but I don't know if we're going to be able to find it. Anyway, let's take a look at some more of these plants. And Cribhouse says, your voice is exactly how I would expect a paleontologist to sound like. Well, I'm glad I fit the expectation, the archetype. Welcome to Paleontologizing. It's good to have you here. I'm trying not to project my voice too much, so we're kind of toning it down a little bit. Because the guys are working down there, and I don't want to be too obnoxious while they're trying to concentrate. So... yeah. Again, welcome to the Turtle Hill site near Green River, Wyoming, in the Late Cretaceous Almond Formation. All these rocks have been placed here by the crew. We've got some incredible fossil plants. Really, really beautiful. I mean, some of these look like they could have just fallen off the branch yesterday, like this one right here. Kind of see those veins on there? Yeah. Lovely. So, part and counterpart. Same with right here. You gotta be really careful with these because they are delicate. Plants like this are very scientifically informative. So it's really important to collect them because they can tell us so much about what this ancient environment was like. Leaf unusual veins right here. Nice. Not the prettiest, but that must have been a really weird looking one. Yeah. Very nice. And then look at this. Holy moly. Look at that. Absolutely gorgeous. You know, I've not really collected a lot of fossil plants in my day. I wonder what the best method of preserving them is. Yeah. But take a look at that. See those veinations? The pattern like that, just beautiful. And then look at that one there. Absolutely gorgeous. Yeah. So not only are they scientifically important, But they're beautiful too. They are beautiful. Swoop says that looks like a modern alder leaf. Interesting. You know more about this than I do. Yeah. And Scavenger Hyena says, ooh, that's totally rad. Those veins and everything. Isn't that cool? Yeah. Yeah. Pretty awesome. We're so lucky to be able to work this site. We're so lucky that this is kicking out such beautiful specimens. Just lovely. And you know, when vegetables or fruits existed at the time? No, this is way before that, Lokemax. Almost all of those are going to be angiosperms, and modern fruits as we know them today evolved during the Cenozoic, during the age of mammals, after the dinosaurs. Yeah. Yeah. And that makes sense, Charlie's Dragon. Yeah. During, like, the Ordovician and Devonian period. Yeah. And do you collect the plant fossils? Absolutely, Chicken Bacon Swiss. Yeah, that's why they're up here. So these came down here from the quarry, and these are going to go back to Cincinnati to be studied by paleobotanists, by scientists who who specialize in fossil plants. This is exciting stuff because we don't have fossil plants from this particular time and place, so it's a good chance that some of these are going to be new genus or new species, I presume. Yeah. And mammals evolved before fruit? Oh yeah, way before, Rave turned. Mammals evolved almost at the same time as the first dinosaurs. Although you had, like, mammal ancestors that evolved before the first dinosaurs. Mammal ancestors, you know, like kind of basal synapsids, ruled the Earth before the dinosaurs did. And then they really got hit hard by the Permian extinction event. And that's kind of what allowed dinosaurs to take over during the Triassic period. All right, you drive safe, Lenina. Thanks for being here. Yeah. And Science Streams, how are you doing? Welcome. It's good to have you here. Stixu says, oh look, yet another rock. I mean, there are a lot of rocks around here. That's why we're out here in the first place. But take a look at some of these. These fossil leaves like this. Just gorgeous. Absolutely beautiful. You see those veins on there? Right here? Lovely. Yeah. Some special stuff. This is a really neat site. Take a look at this one right here. 73 million years old. And you can still see those veins on that leaf. Just exquisite preservation. Really, really nice. Yeah, I'm sure with some of these they pull them up and there's like bits that just immediately flake off. Just like it were a dead leaf that, you know, fell off the tree a week ago. Yeah. And I am having a great time out here, Mona Sue. How are you doing? Welcome. Yeah. And have I discovered any Ankylosaurus bones, asks Rachel Rain. If not, do you have any facts about them? They're my favorites. So I have actually, yeah. Ankylosaurus, I found some scutes, some osteoderms. Ankylosaurus is one of the very last of the ankylosaurs. It lived at the very end of the Cretaceous period alongside T-Rex and Triceratops and Pachycephalosaurus. Find them in the Hell Creek and the Lance formations in places like Wyoming and Montana and the Dakotas. But yeah, I found a few osteoderms before. Those are the armor plates. I've never dug up an Ankylosaurus skeleton, but other kinds of ankylosaur, other members of the same ankylosaur family, I have dug up. We've got what's hopefully a new species of ankylosaur, new species of the Nodosaur subfamily of Ankylosauridae. Or I guess it would be Nodosauridae. It is a family. Anyway, a new one from the Judith River Formation up near Rudyard, Montana. And I dug that up in 2017 with Denver and Liz Fowler. Yeah, there was a news piece about that. It's cool stuff. We're pretty proud of that. So yeah, ankylosaurs are neat. They're really neat animals. And later in the summer, we'll be streaming again with Jim Kirkland, the state paleontologist of Utah. And he's an expert on ankylosaurs, on that whole family of dinosaurs. And he's named a few of them, like Gastonia and Mimorapelta, and yeah, I think a few others too. We'll ask him about it. So stick around. That'll be in mid-July We can do that. I'll be out there in Utah from mid-July to mid-August. You got your rock saw, Bibanoff? Yeah, that's at a different site right now. But yeah, we got that going. Ethan's using that. What happens to a fossil/creature that's fossilizing that you can find a few armor plates but not a skeleton in an area? Oh, here. I'm trying to see what the usernames are. That one guy. Yeah, that's what we call taphonomic processes, like everything that happens in between an animal's death and then when it actually gets, eventually discovered, I guess. A lot of things can happen to a critter after it dies. Holy cow. It can be, eaten by a predator. It could be torn apart by scavengers. You have wind and rain that can scatter the bones. In order to actually get something preserved, it has to be covered by sediment. Like, it's got to get buried. And there's a lot that can happen to a carcass before it gets buried. And even a lot that can happen to it after it gets buried, too. So sometimes we only find a handful of bones of a given dinosaur. And that's because there's so much that's kind of working against preserving the whole thing. It's very rare to get a complete skeleton, especially of a large animal, because, yeah, a lot can happen to a critter before it gets buried. Think about, like, if you've ever been out walking and you find, like, a coyote skeleton or a cow skeleton or something. Like, you're not going to find every single bone there. There are scavengers that are ripping it apart and eating it and then scattering the bones around. Yeah. Does that make sense? Yeah. And let me caution, thank you for the 11 months. I appreciate that. Yeah. And Johnny Shoes, oh yeah, that's what I'm trying to do here. Welcome back. Yeah. And are there any chances of finding a preserved mushroom/fungus decomposing a creature? Retrorine, I don't know. That's a good question. Finding the actual, like, fruiting body of the fungus, those tend not to last very long. But you might find some sort of degradation of a skeleton that might be associated with, like, fungal growth. One example of a fossil fungus that I can tell you about is there's a dinosaur who's been nicknamed Dolly. She was a diplodocid dinosaur, like Diplodocus. Might be Diplodocus, actually. But, she died before she reached her full adult, growth stage. And it's very clear that she had a respiratory infection, because her neck bones have got this weird, almost cauliflower-like growth pattern to them that it looks just like when modern birds get a respiratory infection. There's a disease called air saculitis, when you get like a fungal infection, and then that creates a secondary bone infection, and the bone gets all deformed. She had that. So it might have been caused by something like aspergillosis fungus. So yeah, that's a fossil fungus right there, I suppose. Or at least the results, that's a fossil fungus that left evidence. It's a fungus that left evidence in the fossil record for us to find. It's a really cool story. I mean, poor Dolly, but she did not die in vain. We've been able to learn a lot from her skeleton. So, it's pretty cool. And it is extremely rare, says Diagonal, but there are a few such fungi preserved in amber or in chert. I did not know that, Diagonal. Very cool. Thank you. Yeah. Awesome. Yeah. Diagonal, have you ever worked on Cretaceous plants? We're really, really excited. Every single slab that you see right here that's been laid out was brought up from the quarry down there. And every single one of these contains an interesting plant fossil, probably worth collecting. So we are excited about that. Yeah. An aspergillus. Yeah, thank you, Science Streams. Yeah. Yeah. Yeah, and then here, in this area, we've got all of these fossil mollusks. So we've got these beautiful freshwater clams, and we've got some still in situ down there that I'll show you. All these little guys, little clammy clams. Got some fossil snails in here. So this shows us this was a freshwater environment where you had these kinds of invertebrates living and dying, doing their thing. 73 million years ago. Very cool. Yeah. Yeah. And Dracu says, is there any evidence that's suggesting that not all dinosaurs laid eggs? Yeah, shoot. I mean, we've got at least very strong inferences that about half of dinosaurs didn't lay eggs because they were male. But no, all female dinosaurs that reproduced laid eggs. As far as we know, all across Dinosauria, everybody was oviparous, you know? We don't think any dinosaurs gave birth to live young. For a while, we were still missing eggs from a few major dinosaur groups, like ceratopsians. And we've started to fill in those gaps. It turns out they might actually have leathery eggshells, which might make it a little bit more difficult for those to get preserved, and hence, that's why their eggs are so rare. Hard-shelled eggs are easier to fossilize. If that makes sense. Yeah. But yeah, we've definitely got theropod eggs, you know, in great number. We've got ornithopod eggs, tons of duck-billed dinosaur eggs, like Maiasaura. We've got lots of sauropod eggs. I don't know if we have any thyreophoran eggs yet. I bet you we do, and I'm just not aware of them. But from armored dinosaurs, you know, ankylosaurs and stegosaurs and their relatives. Yeah. No pachycephalosaur eggs yet, as far as I'm aware. But as far as we know, all dinosaur species laid eggs. Yeah. Yeah, plant seeds may not have existed at this time either. Chicken, bacon, Swiss. No, there are definitely plant seeds from this time. Yeah, we've got lots of seed-bearing plants from the Mesozoic. You got to go back further in time to when plants only had spores. Yeah. By this time, during the Mesozoic, during the Cretaceous, plants definitely had seeds. I found a bunch of fossil seeds before. Yeah. Let's see. This is literally the first interaction I've ever had with a paleontologist, says that one guy. What is your number one dream find you would like to have? Oh boy. I don't know. How crazy am I able to get with this? Like total blue sky. You know, it'd be very cool to find the ancestor of all dinosaurs. That'd be pretty neat. Yeah. That's just off the top of my head. You give me a while, I come up with an even cooler answer, I'm sure. Yeah, imagine a newborn stegosaur waving its thagomizer around. So yeah, they didn't have, they weren't born with spikes or plates. Those developed later in life. Yeah. Jim was just talking about this with me the other day. And Sculpin, thank you for all those gift subs. Is that 10 of them right there? I appreciate that, Sculpin. Thank you. Excellent. Thanks for keeping me here on the air, Sculpin, and supporting this channel. Makes it possible for me to be out here in the first place. Yeah. 612 viewers right now. Holy cow. Yeah. Let me introduce myself again real quick after I take a swig of water. I gotta remember to stay hydrated out here. Here, take a look at the landscape while I do that. Wild and beautiful western Wyoming. If you're just joining us, let me introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. You probably know already that a paleontologist is a scientist who studies fossils. Most paleontologists do not work on dinosaurs. Dinosaurs are just kind of the tip of the iceberg. But I work on dinosaurs. We haven't found much dinosaur material at this site yet, called Turtle Hill. But as the name would suggest, we've got turtle pieces. And holy cow, we've got scads of fossil plants here. Just scores of them. And fossil clams over here too. And bits of fossil fish, both bony fishes, rayfin fishes, and chondrichthyan fishes as well. We had some teeth from like a ray here yesterday, I guess. And we'll go talk to the guys in a minute here, I think. But Yeah. And if you found the ancestor of all dinosaurs, how would you tell? That's a great question, Mommy does. That's, I guess if it's a total blue sky thing, then, you know, it'd be great to find the ancestor of all dinosaurs and then for it to somehow be immediately obvious. I don't know how. But yeah, it would have to be from the right time and be kind of just primitive / advanced enough where it's obvious. Where it's like clearly not a non-dinosaur, but yeah. It'd be tricky to find the answer, yeah. That's why I picked that. And Dyson Dinosaur, thank you for the raid. Welcome, welcome. How are you? And how was your stream? I hope you're having a great day. I hope your stream was excellent. Welcome back to the Late Cretaceous Almond Formation of western Wyoming. We don't have much dinosaur material here at this site, but we've got a ton of beautiful fossil plants, fossil clams, and stuff like that. Let's take a look at one of these leaves here. Find you a pretty one. There's a nice one right there. Yeah. These have been brought up from the quarry down there. Yeah. But, I guess the prettier ones are over here in this pile. Stuff like this. I showed you this one earlier, but let me show you again. Look at that fossil leaf. Nice broadleaf tree, presumably an angiosperm. Flowering plant. Very nice. It's cool how quickly flowering plants kind of take over after they evolve. And that might have something to do with the evolution of ornithischian dinosaurs like iguanodontians and hadrosaurs. Dyson Dinosaur could tell you about that. Go give him a follow if you're not yet following. He's also a dinosaur paleontologist who streams here on Twitch. Usually in Italian, but he's been doing these English streams on Saturdays, and I've been able to catch one of them so far, and it was a good time. So go check him out. Yeah. But yeah. Oh, and we had a question too about stegosaurs and how they, if they're not born with the spikes and the plates, then what are they made of? They're made of bone. Yeah, those osteoderms, the plates and the spikes, but they, you know, a lot of dinosaurs change a tremendous amount throughout their lifespan, and that's one of those changes that we see in stegosaurs. Yeah. And there were some broadleaf gymnosperms more common in the Cretaceous. Only a few survive today. What are those, Diagonal? I'd love to know about those. Are ginkgos considered broad-leaved gymnosperms? And that one guy says, how can something as fragile as a leaf be preserved, but cartilaginous creatures like Megalodon weren't able to be? Well, the leaves are a lot smaller, for one. And they can just get kind of compressed in sediment like this. And it's easy to find them because when they're there inside of a rock like this, you crack it open, and it'll actually crack along the plane of the plant if you're lucky, because the like leaf in there kind of subtly makes it weaker along that plane. So if you crack it just right, it'll crack along that plane that has the leaf in it. Yeah. But yeah. And Twitcher 2012, can you remember what the first fossil you dug up yourself was? I do remember, yeah. I was like 10 years old, maybe 11. And it was a fossil bivalve, a clam, in Martinez, California, near where I grew up. Yeah. Probably Pliocene in age. It might be like Briones Formation. But yeah. Yeah, I remember it quite well, actually. It was in a park kind of near where I grew up. Yeah. And Zila Beerbo says, my friend discovered this stream and showed me this. Delighted that something like this exists on Twitch. And immediately loving the energy. As a natural sciences nerd, I instantly follow. Glad to listen. It's great to have you here, Zeal. It's great to have you here. Thanks for joining us. Let me know if you've got any questions. I appreciate the kind words and the enthusiasm. Welcome. Here, let me go show you the quarry down here. Yeah. And yes, the larger the creature, the less chance of preservation. Exactly, that one guy. Yeah. We do have some fossils of of sharks, like the whole skeleton. You know, a bunch of vertebrae all in sequence, but they're rare. There's a beautiful one of Cretoxyrhina, also called like the Ginsu shark, from the, I think it's from the Niobrara Chalk, from like Nebraska or Kansas, from the Late Cretaceous. But it's not common to get cartilaginous fishes like that to actually have their bones preserved, because they're made of cartilage. Yeah, it does happen. But generally, the larger the animal, the more difficult it is to preserve the whole thing. There are definitely bones of megalodon that have been found, but never anything close to a complete skeleton. So that's why our estimates of how big megalodon was are just that. They're estimates, because we don't have like a decent vertebral series as far as I know. You've got to basically estimate the size based on the teeth. You got to estimate the size of the animal based on the size of the teeth, and based on the size of the few preserved vertebrae that we have. That's my understanding, at least. I don't work on fossil sharks, so you know, find an actual expert if you really, really want a solid answer on that. Yeah. And another raid, holy cow, from Agathor. Thank you for the raid, and welcome to Paleontologizing. It's good to have you here. Agathor, how was your stream? I hope it was really good. Welcome to wild and beautiful western Wyoming. We're here digging up fossils to go back to the Cincinnati Museum to be studied by paleontologists long into the future. We're out here trying to contribute to science in our own small way. And I'm glad you could be here to watch. Let me know if you've got any questions. And got a PB, a peanut butter in speed run. Very nice, Agathor. No, PB's got to stand for personal best, doesn't it? Good for you. Congrats. That's got to be a good feeling. And thanks for bringing all your viewers here. I appreciate it. Hope you're here to learn. We've got some cool stuff to take a look at. We've got a ton of fossil plants up there that I'll show you in a little bit. But this is the quarry here at the Turtle Hill site and the Late Cretaceous Almond Formation. Yeah. Yeah. Let's see. Oh, it sounds like they might have a vert over there. You mind if I bring the camera over for a sec and take a look?
Of course.
All right. Nice. So here's 3/4 of our crew from Cincinnati. We've got Bob and Cameron and Glenn. Yeah. And what are we looking at here, Cameron?
I'm just stabilizing some fossils on this fish bed we're working on.
Nice.
Just found vertebrae.
Ooh. Fish
And
vertebrae have got a
bunch
really
of-
distinctive shape, so maybe we can take a look at that. If it's, it might be too small for the camera to really pick it
It's
up.
just poking out right now. Let me see if I can uncover it a little bit.
Yeah. So that's one of the reasons why this is such a cool site is we've got different lithologies here that are preserving different organisms. So you've got the big blocky sandstone up there, all those gorgeous leaves, and then here, and that's much more friable stuff, you've got all these little tiny bones.
You can kind of see its shape.
Nice, okay. Yeah, very cool. Give us a rundown. What have we had from like this area over here so far? What kinds of critters have you been finding?
It appears mostly fish bones.
Nice.
We have a lot of amide fish,
Nice.
possibly.
Those are like
Presume-
bowfins, if you're familiar with those, Chad. Yeah.
Maybe of one individual, maybe of several. It's no way of telling. Nothing really articulated yet.
Yeah.
But abundance is definitely
Nice.
a thing here.
Yeah. Yeah. Very cool. And tell us about the tooth that you got the other day. Was that yesterday or the day before?
What?
Yeah.
Yeah, was it yesterday or the day before?
Day before.
Yeah.
The days run together out here, as you can imagine.
Yeah, it was a large bowfin or amide.
Yeah, yeah.
With a really fat bulbous root. It was
Uh-huh.
really nice. Probably about, what was that, inch and a half, 2
That's
inches long.
enormous for
Yes.
a bowfin. That's huge. So how big would that animal be, you think, when it was alive?
Maybe as much as 3 meters. Maybe not quite that, but
It's like close to 10
It's
feet,
big.
maybe.
It's big.
That's crazy.
It was a big tooth.
Yeah, that is so cool.
Yeah, so we found the
Mhm.
amiids. We found teleosts in there. Teleosts are
Nice.
modern bony
Mhm.
rayfin fish. We can recognize those by their spool-shaped vertebrae.
Yeah.
The amid vertebrae are a little different shape.
Mm-hmm.
We found some freshwater ray teeth.
Nice.
So we know there's a diversity of stuff in here.
Yeah.
When you have a chance to come around, just expose a rather large bone up here.
Oh, yeah, let's take a look at that. Thanks, Glenn.
Yeah.
Cool. Let me carefully scoot out of here. Not knocking anything over. Let's see. Let me go down there so I don't have to stumble over the guy line. But yeah, pretty cool, right, Chet? Holy cow. Yeah.
No, over there on that side.
And Denjoga, don't do that. You get alcohol poisoning. If you take a shot every time I say yeah, no, don't do that.
Ontogeny.
Danny, you can step right here.
Excellent, thank you.
Here's that vertebrae getting covered a little bit more.
Nice. Oh,
yeah,
yeah.
That is the bone.
Nice rounded edges there.
This is the bowfin we were talking about.
Very nice. So we were saying we think it might be genus Melvius, which is kind of a well-known bowfin. I found Melvius bones up in the Hill Creek in Montana. Yeah, bigger than your modern bowfin, which is genus Amia. Yeah, bowfin are such cool fish. Take a look at a video of a bowfin if you get the chance. There's a really cool one on YouTube with like a mother bowfin just kind of guarding her little brood of bowfin fry, little baby ones. And they make excellent parents. It's really cool. Yeah. All right. Can I step right here?
Yep.
Yeah,
Okay.
anywhere in there. If you want to put your foot
You
there.
can step
that's
here
fine.
too.
Nice. Okay, thanks.
Actually, it pinches out right here. The layer does.
Great,
What we're
okay.
looking at, so.
Nice. Oh, look at that. Yeah.
Yep, little vertebrae.
What do you think that's from, Glenn?
Well, it's a fish, but beyond that, I can't tell.
Huh.
Fish bone has that sort of waxy texture.
Yeah.
Typically
Really
flat.
distinctive.
Yeah, it's quite distinctive.
They're robust.
But there are obviously a lot of invertebrate bits in here.
Mm-hmm.
Here are two of the unionids in the same horizon.
Big old clams.
Yep. So what we're trying to do is determine where the turtle bones we've been finding
Yeah.
in float are coming from. We think it's kind of in this layer somewhere, so we're working on that.
Mm-hmm.
See what we can see. Ultimately, we want to get down to the fish layer, which is very productive. So,
Nice.
yeah,
Very cool. Thanks for showing us. Let me get
Sure.
a close-up of that.
it's taken
That
quite
bone
a
right there.
bit of work to get down to the spot.
Yeah, I can imagine. Shoot. This site looks completely different from, just a, few days ago. This is incredible. You guys have been doing some amazing work here.
Thank you.
Yeah. Awesome. And this is a very, what we would call a technical site. So, requires a lot of expertise. Yeah, really, really fine scale tools. I'm glad those tiny little awls are good for something.
These are amazing.
Yeah,
this is
so-
the best tool for this.
Yeah, Chat, you bought those, by the way. Those were on the Amazon wish list.
Thanks, Chet.
And we thought they were about 4 times bigger. But as it turns out, they're perfect for this, so that makes me happy. Yeah. Nice. Yeah, shoot, a bunch of the gear that you're going to be seeing here, Chat, is stuff that many of you purchased off of the wish list, so thank you again. We are deeply grateful.
We certainly
Yeah.
Absolutely.
Yes. For somebody who forgot their rock hammer. Right?
Yeah. Everybody always forgets something going out to the field. For me, I forgot my pillow.
That's not
So-
a good one either.
Yeah, Ethan picked me up a cheap one from Walmart a few days ago, so I was grateful for that. But, yeah. Anyway, cool. Thanks so much for showing. Somebody had something about unionids in the chat. Let's see. Where did that go? Dial Tones wants to know what time period do these... the asteroid hit 66 million years ago, give or take a few 100,000 years. We think these rocks are about 73 million years old. But we're working on getting an actual radiometric date, so we've got a solid number for that. Yeah, check in a few months. Maybe we'll have that. That would be really cool. Yeah. And, Ken is back too. Hello, Ken. Loss of service? Oh, shoot. Here. Yeah. Let's see. All good. Okay. Okay. Yeah. Let's see here. And Dinosaur Dave, Australia Zoo yesterday. Very cool. It bit your dad. A cassowary bit your dad on the finger. Didn't draw blood, but got a great photo in the Discord. Very cool. Thank you, Dinosaur Dave. Just in time for Thursday Birds Day. Yeah. Oh, and that one guy. No, I didn't say that a bowfin was guarding her babies and then they got fossilized. There's a video you can see of a modern bowfin guarding her babies, or maybe his babies. I don't know if they have dual parental care, or if it's just the mothers primarily, but either way, it's really cool. Check it out. Somebody can find it and then post it in the chat. Yeah. But yeah, and very funny Steve X Racer. Welcome to Paleontologizing. And Princeton Inertus says, have you ever come across any mosasaur fossils? It amazes me how big they got. Well, they did get big, but, you know, up to about 12 meters. Glenn here has actually worked on mosasaurs, and Takuya, who's also from the Cincinnati group. He's at a different site today, but he specializes in mosasaurs. Yeah. So we've got several mosasaur experts here on the crew, on our field crew right now, which is pretty neat. They are awesome animals. Evebug says, I've wanted to be a paleontologist since I was a child. I can't believe I'm able to see a live dig. Well, welcome. I'm glad you can. This is such a privilege to be able to bring this to you, and I'm glad you're here. Yeah, what a neat site. Turtle Hill here. So you can see this big blocky sandstone like this. Stuff is hard to work. So they've been going at this with picks and hammers and chisels and cracking open these blocks here. Right here we've actually got a bit of fossil plant. You can actually see right there the veins in that leaf. This isn't a particularly pretty one. We might not even collect this one. Maybe we will. But look at those veins right there. 73 million years old. And look at that right there. Shoot, I'd think about collecting this one. Nice. Jesse, are you the one making the calls on which ones of these to collect? And
Yeah, I've got this layer right here.
nice.
That we're waiting on the saw to extract.
Gotcha.
Like, if you want, I can uncover the poncho.
Yeah, awesome. Yeah. This is so cool. How many of you woke up this morning in chat and thought, I'll definitely be watching a fossil dig live on Twitch today? Here we are. Look at those leaves. Holy moly. Gorgeous. Look at how big this one is. Look at that. Wow. And look at those veins on it. Just gorgeous morphology. Wow. And look at these. Holy cow. So again, for the dozenth time, not only are these pretty, but they're also very scientifically informative. Like, these are important specimens that we're getting out of here.
Most of the ones on this layer don't last. So
Uh-huh.
It's like, snap a picture of it because you brush and it's gone.
Yeah, shoot. So delicate. Yeah. Yeah, it makes me wish, like, we had a paleobotanist on the crew. I don't know how to preserve these things. I assume that you hit it with some of the glue and then it just kind of deforms.
So you can't glue the layer itself or it will ruin what's on there.
Yeah.
So just kind of, if you do, you'll glue around it.
Mm-hmm.
Or you just try to get the whole slab out.
Huh. I want to say that I've seen a trick where you spray it with hairspray or something like that. Or some sort of like fixative spray. But, yeah, I don't know. Yeah, this is so cool. Oh, thank you, Jesse. This is really neat.
Ontogeny.
What about... Let's see, maybe... I'm not going to make you do it right now, but maybe when you're cracking some more of these layers open and looking at stuff, we can take a look.
Take out that layer.
Nice. So we can actually watch the process. because I think that would be important for people to see. Excellent. And you can undo PVA, right? Exactly, Wombat Hole, yeah. But the thing is, if the liquid itself wrecks the structure of the plant, then you can't undo that. But yeah, that's why we use PVA glue. Polyvinyl acetate is because it's reversible. It's really important when we're dealing with fossils. Ask any fossil preparator or collections manager. They'll tell you. Yeah, super cool. And Jairish says this is a really cool stream. Thank you, Jairish. I appreciate that. It's good to have you here. Tell your friends. And Itsy Bitsy Bone says it's really wonderful that you educate the public for free on paleo stuff. Yeah, I mean, I guess it's not entirely for free. This is how I make my living, through the generosity of the viewers here. But yeah, this is my passion. This is what I'm into. This is what gets me out of bed in the morning, and it's wonderful that I get to share it with you. So, thanks for being here. Yeah. Yeah. And how many bones did you find today? I personally have only found a couple of bones today, over at the Ceratopsian site, and that's not. Yeah, we mostly did some overburden there this morning. I dug around for a little bit. No, maybe I didn't find any bones today. Yeah. Well, yeah, I don't know. I've not really been focusing on any one of these particular sites that we've been working. I've been kind of bouncing around to different ones, helping out where I can, helping to train some of the new people, and then doing these live streams. Yeah. Let's see. Your cat also gets you out of bed. Well, I don't have a cat, Hike the Earth. What do you mean? No, I do live with 3 cats, but they're not mine. They were there before I lived there. Yeah, they're kind of my landlords in a sense. I'm not in charge of them. It's really the opposite. Yeah. But yeah. Simple enough question for me to ask, but possibly harder for you to answer. What's your favorite dinosaur, and have you been fortunate enough to find its fossils? Yes, and my favorite dinosaur is yes, and yes, I found its fossils. No. Yeah, I do have a few favorite dinosaurs that I have found their fossils, and some of them are brand new. Like, I don't know. There's a Ceratopsian that I found back in 2012, which hopefully is going to get published as a new species before too long. It's been a while. It's been 12 years so far. Almost 12 years. But yeah, that's one of my favorites. Doesn't have a name yet. Not a published name, anyhow. And let's see, other dinosaurs that are some of my favorites that I've also found fossils of. Leptoceratops is a good example. Pugnacious little, almost triceratopsy looking dinosaur, but without the horns and without the big frill on the back. Maybe about the size of a very large dog. Kind of a, German Shepherd sized, hornless, horned dinosaur. I got to work at a bone bed of Leptoceratops back in 2013 and 2014, and that was pretty special. It's otherwise a very rare dinosaur, but we kind of figured out the secret to finding him, which I can't tell you about yet.
Ontogeny.
But that'll be published hopefully pretty soon. It's really exciting. That dinosaur, it's going to make that dinosaur a lot more popular once that gets published, I'll tell you that. Yeah. I don't know. I've got a lot of different favorite dinosaurs. And they tend to be ones that I've worked on. Ones that I've worked on in the laboratory or dug in the field. Or like done research on, written papers about, that kind of thing. Yeah. But yeah. And much love. Let's hope we have good weather for the whole expedition. Thanks, Hike the Earth. I appreciate that. And thank you for the 16 months. Excellent. Yeah. Leptoceratops, that one guy. Pretty cool animal, right? Yeah. It'll be even cooler once that paper's out because it had some interesting stuff going on that I can't tell you about yet. Let me drink some more water before I forget. And ever stream the laboratory side of the work? Not really. Yeah, just because I usually stream from home, and, you know, I can't really call my office the laboratory. But yeah, maybe one of these days I'll... You know, actually, a few days ago I did stream from a facility at the Utah Geological Survey. You could call that a laboratory. Stream with Jim Kirkland. Check that out in the VODs. That was big. Like 10,000 viewers on that stream when we were looking at the big Utah Raptor mega block. This huge block of rock about the size of a car that it's got the remains of at least a dozen Utah Raptor dinosaurs in it, and probably some other new species as well that haven't been named yet. It's exciting stuff. And let me put on some sun-blocking lip balm too, before I forget. Oh, and Paleo Ken, thank you for reposting that from Scavenger Hyena. Hope you're doing well, Ken. It's good to see you. We're looking forward to having you back here. When you get a permit to dig on public land, you need a repository. Oh, you're replying to Scavenger Hyena. There you go, Ken. Thank you. Yeah. And Jim's garage was interesting. Thanks, Wombat Hole. Yeah, that was a fun stream. That's not Jim's personal garage. It's at the Utah Geological Survey. But that was a really fun stream. I really enjoyed that a lot. There we go. It's important at high altitude here. Take care of your lips and protect them from the sun. Imagine being a human and coming across a Utah raptor. You'd be so toast. Yeah, Princeton. Or it's a big animal, full grown. Oh boy. Yeah, like polar bear sized. But probably a lot faster than a polar bear, and with bigger teeth and much, much, much bigger claws. Miss you all. Feelings mutual, Ken. We're really looking forward to having you back. Yeah, you'll be back this weekend, right? Yeah. And that was a great stream, and I'm not just saying that because Utah Raptor is my favorite. Thanks, Azanku. Yeah. Danny, do you have sunscreen on your ear? Folks are concerned about the laser light coming. Yeah, I wouldn't worry about it too much. I do have a bunch of sunscreen on there, so don't be concerned, honestly. Yeah. And there you go, Fitzhowie. Yeah. Here, I got dust on here. Get that off there. Good, yeah. Let me show you the in situ clams that we have there. These beautiful unionids right there in the block. Walk it down here. So, you see those big sandstone blocks down there, kind of at this angle? Oh, just regular old rocks, right? Nothing special to see here. Let me show you. This is so cool. Hopefully we're still getting signal right now. Yeah. Take a look at those. Yeah. Look at these beautiful freshwater clams right here. So many of them. Holy cow. Really gorgeous. Yeah, clam time indeed. Look at that. So this site is called Turtle Hill because originally the most prominent fossils were turtle bits, but there's so much more here. It's almost a misnomer to call it Turtle Hill. Yeah. They do almost look fresh, don't they? Yeah. And Dr. Hubbs, yeah, look at these unionids. Really awesome. Yeah. That way, would that mean that this area had higher energy water, maybe rapids? You know, I'm not sure. I don't really know enough about to be able to say what kind of environment they represent. But maybe we'll ask Glenn in a minute if we're not bothering him too much. Yeah, this is not the sort of thing that I'm an expert in at all, but it's really cool to see. You know, even as a dinosaur guy, I can 1,000,000% appreciate this. And the idea is hopefully we can get these back to camp and then get them back to Cincinnati, because this would make a wonderful display piece. So any of you in the state of Ohio or nearby, you know, Kentucky, West Virginia, anywhere like that, if you make a trip to Cincinnati anytime in the nearish future, maybe, just maybe, you'll get to see this. Either in the laboratory, like in the viewing lab, or maybe out on display at some point. Might be a few years, but something to look into. Yeah. And we did not polish these. This is just how it looks. You know? Pretty cool. Think about what it'll look like after it's been cleaned up a little bit. And as you can see, there's a bunch of lichen growing on it right here. This has been out on the surface for a long time. Lichen does not grow quickly. It is very, very, very slow growing. And so you can tell this has been exposed on the surface for a good while here. Years and years. Pretty neat. Here, let me clamber back up here and answer some more questions. Yeah. Or maybe we'll see if we can ask Glenn about those unionids. See, can we bother you for a second, Glenn?
Absolutely.
Yeah. So we're just looking at those beautiful unionid clams there.
Aren't they great?
Yeah, incredible.
Yeah.
You're talking about maybe taking one of those slabs back to Cincy to put on display, you think?
Yeah, I think that big one that you're probably showing them would make it a fantastic exhibit specimen next to our Daspletosaurus, which is a Cretaceous tyrannosaur.
Nice,
It's one of the things we're doing while we're out here, and also in our exhibit in Cincinnati, is we try to highlight the contextual data, the flora and fauna that goes along with the dinosaurs that everybody loves.
Yeah.
And that'd be perfect for that.
Definitely, yeah. Yeah, what does that tell us about this environment? Are these are presumably fresh water, right?
They're definitely fresh water.
Yeah.
They need a well-oxygenated environment, of course.
Gotcha. So like running water, nothing stagnant.
Running water, probably.
Yeah.
Certainly not stagnant. It doesn't necessarily be a fast-flowing stream or anything like that. But well-oxygenated. Interestingly, I think these are disarticulated valves of the bivalves. So they come apart. They're dead. It's a death assemblage.
So
But they're not broken up. So they haven't traveled very far.
Gotcha. So they were killed by maybe too much sediment or something like that?
Could be influx of sediment. We see that this area has a lot of fluctuating environments between stagnant marshy areas, flowing streams, freshwater limestones represent ponds with leaves falling in them, things like that.
Cool. Neat. Well, thanks.
Sure.
Appreciate it. Yeah. So yeah, if any of you are in the Cincinnati area at any point in the next few years, you might get to see that in person. And make sure you visit the museum. If you're anywhere near Ohio, the Cincinnati Museum is a pretty awesome place, I am told. And I'm really excited to go at some point. Yeah. Yeah, let's walk up here for a bit. And Nuno says, why does it take so long to publish a new species or article such as the ones you mentioned? Oh boy, there's a number of different reasons. It can take years to dig something up. It can sometimes take a long time to transport it back to the museum, to the laboratory. It can take a long time to clean. That can be multiple years in and of itself, especially if there's a big backlog. And then you've got to study it, you've got to collaborate with your colleagues, you've got to become as familiar as you can with all the existing literature. When you go to publish a new dinosaur species, for instance, you basically have to become an expert on that entire group. You have to read everything that's ever been written about that particular group so that, you're not missing anything. Then after all of that, after you've done all your illustrations, put all your figures together, written the manuscript, edited it, shopped it around to different colleagues, be like, hey, can you take a look at this for me? Then you submit it for publication. It has to go out for peer review. That can take months or years sometimes. And then once it gets accepted, there might be a backlog of papers in there. You might have to wait another year or something like that before it finally actually makes its way into print, gets published. So yeah, these things can take years, they can take decades, easily. So every scientific paper that you see like that on fossil critters, I just want you to have some sense for how long these things can take, how much time, effort goes into that. There's so much work represented by something like that. And everything that we learn is, building upon what people have learned about in the past and what they've published. And this is very, very, very much a team effort, Nobody does this sort of thing alone. We're all kind of building this great edifice of scientific understanding. And it takes literally thousands of people. Paleontologists in the field digging these things up. The people at museums who are prepping the fossils and curating them, illustrating them, photographing them. You've got people behind the scenes in the museum who are raising funds for the museum to make all this possible. You've got volunteers out here in the field who are like, we wouldn't be able to do this without volunteers. Certainly not. So yeah, it's very much a team effort. Every paper really is kind of a small miracle in a way. That somebody found this fossil, studied it, did everything to do, to get it ready for study, and then, everything goes into publishing it. It's a lot. It is a lot. Babzilla, thank you for the 8 months of support. I appreciate that. Yeah. Have you ever checked out the Alberta Badlands, Connor? Just a little bit. I've actually walked across the border into Alberta from Montana once. Because the Badlands are contiguous between northern Montana and Canada. Northern Montana and Alberta and Saskatchewan. But yeah, I've never really been to Canada in earnest, so no. But we got some of the same dinosaurs down there in Montana, because again, it's contiguous. Yeah. And let's see, I'm just happy the mystery of Dinosaurus was solved within my lifetime. Me too, Deathsaurus. Oh man. I was there in 2013 at the big Society of Vertebrate Paleontology meeting when that was unveiled, and it was a magical moment. Holy cow. This is before it was published, so we all had to keep quiet about it. But, yeah, there was probably, 1/3 of all the vertebrate paleontologists on the planet were crammed into that one room to watch that presentation, and it was pretty special, because that had been a big mystery since long before I was born. What is Dinosaurus? Yeah. But yeah. And let's see... Find some other questions. Yeah. Let's see. Is there going to be a need to update the definition of dinosaur? Birds aren't considered reptiles, yet are feathered like some dinosaurs are thought to have been. So yeah, birds are reptiles. That's the thing, is that when people think birds, they don't think, they're reptiles, but they 1,000,000% are. Birds are a kind of dinosaur, and dinosaurs are a kind of reptile. So birds are a kind of reptile. Yeah, I know that's not what you learned in school, but that's how it is. That's what we found as scientists. I sincerely wish that this sort of thing were properly taught in schools, because most textbooks are way out of date, and oftentimes they kind of shy away from talking about evolution at all because of the influence of creationists. Don't get me started on the lack of evolution education in schools, especially in the U.S. Yeah. Some people are just, I don't know. They're just scared of the idea that living things change over time, but they absolutely do. That's what we see out here. Yeah. Chickens are T-Rexes, says his beardness. So Tyrannosaurus and Gallus, the genus for chicken, different animals. But Tyrannosaurus is related to chickens, and all birds. Not just chickens, but hummingbirds and penguins, ostriches and pigeons and everybody else. Those are all a group of theropod dinosaurs. Let me show you. Break out some of these visual aids. Yeah. There's our one with the birdie birds. There we go. There it is. Yeah. So, we also had a question about, like, the definition of a dinosaur. So the way that we as scientists classify living things is, you know, based on phylogeny. It's not based on vibes. It's not based on what they look like, how we feel about them. When we say that two different creatures are related to each other, we don't just mean they look similar. We mean that they are actually, in a real sense, related to each other. They are relatives, meaning they share a common ancestor. In the same way that, like, you're related to your cousins, if you have cousins, you know, you and your cousins are different. You're not the same people, but you share a common ancestor. You've got, you know, the same grandparents as your cousins. At least two of the same grandparents, or at least one of the same grandparents, in order for you to actually be cousins. Yeah. So you can go back and find an ancestor that you share in common, an ancestor that you both had. That's how we classify living things, too. So right here is like an evolutionary tree, family tree, showing amniote animals. So this is definitely not all animals. This is just the amniotes. Amniotes are critters that ancestrally had eggs that they laid on land. That was kind of the major innovation of amniotes. And not all amniotes today lay eggs. Many of them have lost that ability, giving birth to live young and stuff like that. But there's the internal structure in there. Like, even in placental mammals, you still have an amnion and stuff, and that comes from that original amniote ancestor. Dinosaurs begin right here. So, the way that we classify dinosaurs, what makes a dinosaur a dinosaur? What is a dinosaur? A dinosaur has to have evolved from that common dinosaur ancestor. So everything that evolved from this semi-hypothetical ancestral dinosaur. Here we've got, like, looks like Eoraptor. Eoraptor is one of the earliest dinosaurs we have. So, yeah, everything that evolved from that earliest dinosaur is a dinosaur, including birds. Birds are living dinosaurs, and they evolved from two-legged, feathered, meat-eating dinosaurs, part of the theropod part of the dinosaur group. So, yeah, and then you get all kinds of other dinosaurs throughout here as well. Crocodiles are not dinosaurs, but they are related to dinosaurs. They share a common ancestor. They are both archosaurs right here. So this, I guess, would be Archosauria. Yeah. Yeah, does that make sense? Yeah, so when we say that, like, I don't know. If we're talking about classification, think about koalas, for instance. People call them koala bears, but but they're not actually bears. They're not. They're marsupials. So they share a common ancestor with kangaroos, with wallabies, with bandicoots, with critters like that. They might look superficially like bears, but that's just a coincidence. They've evolved maybe vaguely similar morphologies to bears. Contrast it with panda bears, which actually are a kind of bear. We didn't know for a long time. Some scientists thought that they were more closely related to raccoons, but once we started to actually be able to do things like genetic testing, we could figure out that their DNA is much, much, much more similar to that of, say, a grizzly bear than a raccoon. So pandas are considered bears. Giant pandas, at least, are bears. Red pandas aren't, but that's a different story. They're not related to giant pandas closely. But yeah, and let's see. And that one guy says, gonna go high-five an ostrich now and say, dude, you're awesome, and I'm a big fan of your cousin T-Rex. There you go, that one guy, yeah. Also, they don't really look like bears, koalas. Yeah, you're right, Mayorspace, you're right. Yeah. They are highly qualified. There you go, Miss Yvette. And, Ken says, no one has an issue with bats being mammals, but birds being dinosaurs blows people's minds. Yeah, it's funny, isn't it? Yeah. I guess it's because, bats have got big pinnate ears. They've got, hair. Those are mammalian traits. But I think more people would realize that, like, oh, shoot, birds are dinosaurs if they realized that a ton of dinosaurs had feathers. Like Velociraptor had feathers. Troodontids had feathers. Some tyrannosaurs had feathers. And then some of the sauropod dinosaurs, like basal ornithischians or basal sauropods like Culindrodromeus, pictured right there, I think it's supposed to be Calidodromeus. They seem to have had feathers too. It could be that the very earliest of all the dinosaurs had feathers. Feathers might be an ancestral dinosaur trait, and it could just be that certain groups of dinosaurs, like ceratopsians and sauropods, later on they just lost feathers. You know, they didn't need them anymore, so they just got rid of them. And the same way that like whales are a kind of mammal, they don't really have hair anymore. You know, they got maybe a little bit, but you don't think of whales as hairy animals, you know, even though they're mammals, and mammals generally have hair. Yeah. It might be that, you know, dinosaurs are creatures that have feathers, but some of them just lost that. Kind of like how whales lost their hair. Yeah. But yeah. Way to irritate an Aussie, say koala bear. There you go, Sir Yogi One, yeah. Yeah, I don't say koala bear because they're not bears. Yeah. You could very pointedly say, oh look, there is a koala marsupial. And you might sound weird, but you'd be correct. Yeah. Yeah. And whales with hair is a fun visual. They used to have hair, Sully Wully. Yeah. Yeah, the earliest whales certainly had hair. They also had hooves. Whales are artiodactyls. So whales are a kind of hoofed mammal. Whales are related to things like pigs and deer and cows, and especially hippos. Hippos are the closest living relatives of whales. They actually share a clade that's been called whippomorpha, for like it's portmanteau of whale and hippo. Whippomorpha. So like whale hippo form. Yeah. But yeah. And Keed says, I assumed koalas are called bears because people thought they looked like stuffed animals. You know, that term might actually predate the concept of a teddy bear. Because I don't think teddy bears are... It's like barely over 100 years old, right? That concept. I bet you they were called koala bears even before then. Doesn't the origin of the teddy bear have something to do with Teddy Roosevelt, U.S. president? I want to say that's the case, but I'm not a historian, and I don't know that for a fact. Yeah. And I thought manatees are also close relatives of whales. That one guy, they're not. No. Yeah, so like Diagonal was saying, manatees are part of a group called Afrotheria, which is this really weird group of mammals that evolved in Africa. Africa was kind of an isolated island continent for a while, and so evolution could kind of run wild. You had a bunch of the major mammal groups didn't make it to Africa at first, so you had this one group that started evolving into all these crazy shapes and sizes and forms. We call them Afrotheres. So that's elephants, hyraxes, manatees, and sea cows, dugongs. Who else? Elephant shrews, golden moles, aardvarks. Those are all Afrotheres. They are weird and cool critters. We did a special stream about them. Actually, a couple of special streams about them. For Manatee Appreciation Day and for World Elephant Day. We talked all about Afrotheres just a couple months ago, and that was a lot of fun. Yeah. Africa was the Australia of modern time. There you go, that one guy, yeah, yeah. And Tenrex, too, absolutely, Dr. Hubbs, yeah. But not giraffe. Giraffes are artiodactyls. So giraffes are closer to whales, believe it or not. Giraffes are... They're most close to okapi, which is also, I think, part of Giraffidae, the giraffe family, or Giraffoidea, at least. And then you've got your camels, I think, might be close to giraffes after that. So giraffes are super close to okapi, and then a little bit more distantly related to camels, if I remember correctly, which maybe I don't. If we have any mammal phylogeny experts in the chat, please correct me. Yeah. But yeah. And let's see here. It's like we only had horses, hedgehogs, and rats left from Boreotheria and missed everything in between. That's what makes Afrotheria look like a weird collection of... There you go, Charlie's Dragon, yeah, yeah. Yeah, and pronghorns, thank you, Dr. Hubbs, yeah. Pronghorns are also Antilocaprids, that's the group. And I think they're kind of next to goats, and then goats are next to camels, or no, goats are next to giraffes and okapi. And I think camels are outside of that. So thank you, Dr. Hubbs, yeah. 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 And thank you, Murph. See, I thought I remembered that correctly with Teddy Roosevelt. Yeah. Yeah. Anteaters are actually a different group, Connor. Anteaters are part of a group called Xenarthra. It's so funny we're talking about mammals right now when we're at this site, but, you know, it's always fun to talk about mammals, I guess. Not always. But anyway, anteaters are xenarthrans, so they're related to sloths, and maybe more distantly, I think they're related to armadillos too, and glyptodons. Although they may have been moved to a different clade now, I'm not totally sure. Again, I'm not a mammal guy; I'm a dinosaur guy. And let's see, Doom Shallot, what a great name, says, the only paleontologist I know is Ross from Friends, lol. Well, you know me now. Welcome to Paleontologizing. Let me take a swig of water and do another little station break here. Yeah. Here we go. Here, turn around, I'm trying to drink here.
Ontogeny.
Much better. Yeah. Anyway, yeah, welcome, Doom Shallot, to Paleontologizing, and welcome everybody else. It's great to have you here. My name is Danny Anduza. I'm a dinosaur paleontologist. You probably know already that a paleontologist is a fossil scientist. Well, most paleontologists do not work on dinosaurs. I want to make that very clear. I'm not trying to be a dinosaur chauvinist here. Paleontology is the study of fossils, and that can be the preserved remains of any ancient organism. From fossil trees to pterosaurs, from fossil whales to fossil bacteria. Any living thing that left evidence of its existence in the rock record, that is something that a paleontologist might study. Dinosaurs are just a small part of that. That's the part that I work on. I work on dinosaurs. And we're here in western Wyoming digging up dinosaurs. And I'm doing my best to stream that live almost every day. We're here right now at a site called Turtle Hill, where we've got a few dinosaur bits, but it's mostly lots of other different critters. Fossil clams and fossil fish, fossil turtles, as you might guess from the name Turtle Hill, and lots and lots and lots of fossil plants, and we'll take a look at some of those in a little bit. Yeah. What's the most studied part of paleontology? Asked Sully Wally. Great question. Honestly, as you know, most fossil scientists happen to be, human beings. And so, as human beings, we tend to be pretty interested in human beings. And so paleoanthropology, the study of fossil human ancestors, that's a pretty big field, at least in terms of the number of people who work in that field. It used to be the case that there were more paleoanthropologists in the world than there were fossil human ancestors. I don't think that's quite the case anymore, especially with all these fossils that have been coming out of South Africa. There might finally be more fossil human parts than there are, fossil human scientists. But yeah, that's an overrepresented group. But paleoanthropology, you could say it's part of paleontology, but I think a lot of paleoanthropologists think of themselves more as anthropologists instead of paleontologists. It's interesting how these different fields kind of have loose and hazy borders to them. But yeah, there's a lot of people who are very interested in the evolution of humans. Lots and lots of scientists work on that. I don't. That stuff is cool and all, but, dinosaurs are what I'm interested in. I'm more interested in what was here long before we ever evolved. There's something kind of fascinating and alien about dinosaurs that just captures my imagination. So that's what I'm into. And not all that work with dinosaur bones are paleontologists. Old Bone Mo. Did she work on dinosaur fossils? I thought she just worked on, modern animal bones, Chandra. But anyway, no, but not everybody who works with dinosaur fossils is a paleontologist. You know, you have, I don't know, a paleontologist is what a paleontologist does. So like if you publish on fossils, you are a paleontologist, I would say. If you call yourself a paleontologist and you work on fossils, you publish on them, and you are a paleontologist. But there are also technicians, there are people who do science outreach, there are people who work in the museum fields, there are, you know, preparators and collections managers who might not call themselves paleontologists. Yeah. But for the most part, if you work on fossils, you know, you're within paleontology, even if you aren't a paleontologist, if you don't consider yourself that, you know. Yeah. Yeah. And how's the field today? Volcano Doc, how are you doing? Welcome, welcome. It's hot today. It was like 90-something degrees earlier, which is too hot for western Wyoming at this time of year. But it's been good. It's been good, Volcano Doc. Let me show you around a little bit. We're here at a site called Turtle Hill in the Late Cretaceous Almond Formation. And as the name implies, we got turtle fossils here. We've got fossils of different fishes, both ray-finned fishes and chondrichthyan fishes. You know, cartilaginous fishes like rays. We've got these lovely fossil clams down there that I was showing off earlier. And then we've got scads and scads of gorgeous fossil leaves, which are going to be really important. I don't think there are any plants that are described from this particular formation yet. So this stuff is going to be important. Some of these are exquisitely well preserved. Here we go. Stuff like this. Take a look at that right there. 73 million years old. And it looks like it could have fallen off the tree 2 days ago. Yeah. Gorgeous. Fossil plants like this might not seem as exciting as dinosaur fossils, but they're actually really scientifically important because they help us tell what this ancient environment was like. They help paint a portrait of what western Wyoming looked like back during the Late Cretaceous period, the end of the Campanian and beginning of the Maastrichtian stage. Yeah. But yeah. Anyway, if you're not yet following Volcano Doc, everybody, you're missing out. Melissa is a real-life volcanologist. She's a volcano scientist, and she streams here on Twitch too. So give her a follow. She sometimes does actual science on stream, like working on manuscripts and stuff like that. So if you'd like kind of that perspective on how science works, she does a great job of portraying that. And she's just super cool and neat to hang out with, and she can answer your questions about volcanoes and that kind of thing. And she'll tell you that you don't have to worry about Yellowstone erupting. It's one of the most common questions she gets, she says. So anyway, go give her a follow. Melissa is super awesome. Go follow Volcano Doc. And is this a raid? Well, I think it very well might be. Nega Oryx, how are you doing? Welcome to Paleontologizing. Hello. 163 raiders. How are you all doing? It's great to have you here. Welcome to the field. Welcome to Paleontologizing. Welcome to western Wyoming, out in the middle of nowhere. And in middle of nowhere in a good way, away from the things of man. Welcome to the Late Cretaceous Almond Formation, from kind of near the end of the age of the dinosaurs. We're here digging up dinosaurs, digging up any fossils that we can find that can tell us about what this ancient environment was like, who was living here, and all that good stuff. So, yeah. Now, what is that light keep going on? There we go. Yeah. Streaming to you live via satellite right now. Here's our dish, and our solar battery and solar panel. Yeah. It is a pleasure to have you here. Let me know if you've got any questions. Yeah. How large are these turtles, and were they capable of walking on dry land? Most turtles are capable of walking on dry land, except for sea turtles. They can kind of haul themselves up onto the beach, but they don't really walk. All of these turtles could walk. These are freshwater turtles that we've got here. And we don't really know what particular species they are yet. We've got some bits of trionychid turtles, which are soft-shell turtles, kind of like the ones that we have today. But yeah, maybe we'll go ask about some of those in a minute, because we've got Glenn and Cameron down there, and maybe we can get a turtle tally. Ask them about that. Yeah. Nega Oryx, how was your stream? I hope it was really good. Thank you again for bringing your raiders here. And welcome to Paleontologizing, everybody. This is what I do during the summers. You know, this is what I did long before I started streaming on Twitch. I've been digging dinosaurs and other fossils since 2011. And it's only been in the last few years I've been able to live stream that. And it just keeps getting better and better every year. So I'm really glad you're here. Let me know if you got any questions. Anything I can do to bring science to life for you, let me know. Any amphibians? That's a great question, Miss Yvette. I don't know. Maybe we'll have some salamander vertebrae or something. Let me go ask. Yeah. Yeah. It was great. Thanks so much for asking. You bet, Nega Oryx. I was really, really happy to catch you live. I'm so glad you did. Thank you again for the raid. Yeah. Here, let's go take a look over here. Yeah. Oh, Cameron's doing some important work repairing the shade tarp. They just put this up today. I'm actually really impressed with really limited supplies. They were able to take the same tarp that they used to cover the site every day to protect it from rain and stuff overnight and use it to protect them from the sun during the day.
And the shovels we used to dig.
Yeah, yeah. I mean, look at that. That is some ingenuity right there. Was this your idea, Cameron?
No, it was actually Jesse's idea.
It was Jesse's idea.
Team effort. Well,
nice.
It's Jesse's tarp.
Awesome, awesome. Yeah.
And then we all came together and made it happen.
That's how it works in the field. Yeah. Yeah, cool. And here, Bob, am I in your way?
Yeah, I was going to
Yeah, sorry.
we
Get some reinforcement.
Okay. I think you're probably right about the getting soft.
So, yeah, so Bob and Cameron and Glenn are from the museum in Cincinnati. Well, what's the official name for your museum?
Cincinnati Museum Center.
Cincinnati Museum Center. There we go. We always just say the museum in Cincinnati, and everybody knows what we're talking about. But, yeah. World-class museum. Make sure you visit, everybody, if you haven't had a chance to. If you're ever in the area, do not miss it. But, yeah, we had some questions about the turtles here, given that this is Turtle Hill. What's our turtle tally so far for, like, we've got probably trionychid bits. Any other kinds of turtles, maybe?
Yeah, there are bayonids.
Bayonids?
Sort, I think we might have a docus.
Nice, okay.
Not sure yet, really. But
Yeah.
We got 2 to 3 different sorts of turtles in here. Freshwater, aquatic turtles.
Nice. Bayonids are the ones with the domed carapace,
Real
right?
high-domed, yeah.
Yeah. So
I believe we found them all in float, haven't we?
So far, they've all been in float.
Yeah.
we're
So
trying
none
to
in
find a
situ
way to-
yet.
Yeah.
Hopefully you'll get some, because that'll
Well,
be
we'll
really
get there.
cool. Yeah. You're pretty confident you're going to find them just
I
like
think so.
inside?
We have a lot of ground to cover as we dig into this hill. So.
Yeah, this is great. Holy cow. It's so nice that we've got the shade tarp here, too. Today is way hotter than any of the days we've had so far. So, this is good stuff. Yeah. This almost looks like turtle shell, but it's definitely not. But yeah, and Musorbut wants to know, do you collect pollen and analyze them? Do they preserve in this climate? I don't know if we've really thought much about that yet, but fossil pollen is really, really important for determining what the plant life was in a given area. And you can find pollen grains basically in what we call matrix, just in the surrounding rock like this. But generally, you look under a microscope to find it. Yeah, there will be fossil pollen grains in some of this matrix. But we're not at that stage yet. We're still looking at the macro stuff. Let me show you some of these plant fossils that we've got. Yeah. Oh, and thank you, Claiber, for reposting that from that one guy. What dinosaur has a general public accepted appearance that you don't think is correct? Oh boy, several. Yeah. I mean, could people have figured out what an elephant looked like based on its skull? I enjoy seeing artistic renderings of modern creatures based on skeletons. Yeah, I think we generally have a pretty good idea of what most dinosaurs looked like if we have anything close to a complete skeleton. Mammals are weird. Elephants are a kind of mammal. And as mammals, oftentimes the silhouette of our body really doesn't match the silhouette of our skeleton. Because we've got, weird stuff like we only have ribs on our thoracic vertebrae. Our lumbar vertebrae don't have them. So like, if you were to just draw a silhouette around a human skeleton, you'd make us way thinner through the midsection. Stuff like that. Mammals have those, external pinnae, those like external ears that often swivel around and stuff. That's not reflected in the bony skeleton. A bunch of stuff like that. An elephant's trunk is a good example too. Dinosaurs are not mammals, so they belong to another group called the sauropsids, the reptiles. And in particular, within Sauropsida, they're part of Archosauria, the ruling reptiles, Archosauria. And today, Archosauria, the only living archosaurs are crocodilians and birds. And so, when we're trying to figure out things about dinosaurs, trying to organize our thoughts about dinosaurs with regard to stuff that doesn't fossilize, say you want to know what the eyes of a dinosaur would look like, even though eyes don't fossilize. Well, you look at their modern relatives. You look at crocodiles and birds. And you use those as kind of clues to help organize your thoughts around this. And so the thing about crocodilians and birds is that the outline of their body, and for birds especially under the feathers, their skin and that silhouette there, it hews pretty closely to the skeleton. So, for the most part, crocodilians and birds, if you've got a complete skeleton, you can be pretty confident about what the fleshy outline would look like. Birds, it gets more complicated because they had feathers. There certainly would have been a lot of different feathered dinosaurs that would have had all kinds of crazy feathers and stuff, and maybe that would have changed their overall outline a lot in ways that, we can't really predict, unless we find exquisitely well-preserved specimens that have fossil feathers on them. So yeah. But for the most part, we've got a pretty decent idea about what most dinosaur groups in general, what their representative dinosaurs would look like. Think about duck-billed dinosaurs. We've got mummified duck-billed dinosaurs where we actually have preserved skin and we've got a general outline of what the flesh would be like. And so we've got a pretty decent idea of what those animals looked like in life. Sometimes we can even figure out what colors they were by looking at melanosomes, looking at fossilized color cells in the skin, if they've got preserved fossilized skin, which sometimes they do. So yeah, I hope that answers your question with enough detail. Yeah. And Ms. Blue Skies has got a great question. Why do we have things like frozen mammoths but no frozen dinosaurs? Because there's no ice that's that old. Yeah. When dinosaurs were walking around, Earth's climate on average is warmer than it was today, or especially during the last ice age, during the Pleistocene. And so there's just no ice that exists on planet Earth that was formed during the age of the dinosaurs. Doesn't exist. After the dinosaurs went extinct, temperatures continue to rise and rise and rise until you get to the Paleocene, Eocene thermal maximum, when it seems like there was basically no ice on planet Earth. Essentially zero. No ice at the poles. You could go to northern Alaska, and there'd be, tropical palm trees and crocodiles swimming around and stuff like that, So there's no ice from the age of the dinosaurs in which to find frozen dinosaurs. It just doesn't exist. But yeah. And Gravity says Ice Age and Dinosaur Age are not the same time, I guess. Oh yeah, Gravity. Let me show you, everybody. I've got a visual aid that should help with this a little bit. Yeah, so there we go. This is a visual representation of the history of life on Earth. Or just the history of the Earth. Earth formed about 4.5 billion years ago. Right there. And then the first life evolves, let's see, probably about here, about 4 billion years ago. Continues on like this. And then, turn this around. Phanerozoic, the age of like visible life. Paleozoic era, Mesozoic era, where the dinosaurs evolved, and the Cenozoic era, the age of the mammals. So dinosaurs first evolved about 240 million years ago, give or take. The earliest dinosaurs we have are about 235 million years old. We're about there, and like, earliest part of the late Triassic. And the dinosaurs really take over the Earth during the Jurassic period. That's this blue segment here. And then they continue their reign through the entire Cretaceous period, this green section here. We're digging in rocks from right near the end of the green right there, right near the end of the Cretaceous period. And then that asteroid hits right here between the junction of the green and the orange. 66 million years ago, the asteroid hits. Dinosaurs get wiped out, except for a handful of bird species. And then we're in the age of mammals. So you and me and Twitch.tv are right here at the end of the Cenozoic, at 0 million years ago. Now, the last ice age ended, what was it, about, I don't know about the actual ice age itself, but the Pleistocene, it was like 10,000 years ago. End of the Pleistocene. So very, very, very recent. Last of the ice ages only ended thousands of years ago, rather than millions. The end of the age of dinosaurs was 66 million years ago. Just to give you some perspective here. Yeah. Did many bugs survive, Quillhorst? It seems like a lot of insect species also went extinct at the end of the Cretaceous. It was maybe something like 80% of all species on Earth died out. We're still trying to tally this up and figure it out. You hear different estimates from different researchers. But man, it was a bad time to be a critter on our planet Earth back then. Like that was rough when that asteroid hit. And it was a case of the meek inheriting the Earth. Creatures that were relatively small, seemingly insignificant in their ecosystems, those were the critters that tended to survive. All of the big, flagship animals like dinosaurs, mosasaurs, plesiosaurs, all the ammonites in the ocean, everything else, they all, they bought the farm when the big one hit. They all died when that asteroid hit. Yeah. It paid to be small. It's a case of the meek inheriting the Earth. That's why we're here today. We would not be here today if it hadn't been for that asteroid impact. Our mammal ancestors managed to survive, and then they took over the Earth after that. So, yeah. Let's see. Why couldn't spiders have been made extinct then? Oh, man. Something else would have evolved that would probably be even scarier. That one guy. So, count your lucky stars that what we have today are spiders and not something you'd find even more unsettling. Fujoshi says humans are not meek. No, but our ancestors certainly were in the Mesozoic. The mammals that survived, our ancestors, the direct ancestors of humans, were little shrew-like guys, little squeaky mammals that lived in burrows. They'd lived in the shadow of the dinosaurs for 150 million years. And it's only because of that asteroid that they were able to diversify into all of these enormous, the enormous diversity of mammals that we see today. That diversity was significantly less during the Mesozoic, let me tell you. Yeah. But yeah, and what did alligators and crocodiles evolve from? So there were crocodiliforms, during this time. We might even have some bits of croc here. But yeah, so crocodiliforms that you would recognize as crocodiles, they first evolved in the Jurassic, I believe, during the age of the dinosaurs. And they actually did really well. It doesn't seem like many of them go extinct at the end of the Cretaceous. They survived. And it might just be that, when you're hanging out in swamps and just eating dead stuff sometimes, and if you can burrow into the ground and estivate for a long time, which crocodiliforms are pretty good at, then you survive when the asteroid hits. That seems to be what happened. Yeah. And we got more raiders here. Holy cow. Let's see here. Hoot House live stream. How are you doing? Welcome, welcome, Hoot House and Raiders. How are the owls doing, and how are the hawks doing? It's great to have you here. Welcome to beautiful and very sunny and warm today, western Wyoming, out here in the Late Cretaceous Almond Formation. We're digging up dinosaurs and assorted other cool critters, and I'm glad you could be here. I'll show you the quarry. Yeah. And modern crocodiles is in the common ancestor of all modern crocodiles. Yeah, Leaf MK. I think you're right about that. That's why I was careful to say crocodilomorphs. But yeah, I think the ancestor of today's modern, like genus Crocodilus and genus Alligator, I think their common ancestor did evolve in the late Cretaceous. Yeah, and I found fossils of them like Brachychampsa and Borealisuchus in the Hell Creek and in the Judith River formations. But yeah, here's our quarry here. This site is called Turtle Hill, and there's only a few bits of dinosaur bone that have been found here. Yeah, Jesse actually found what's that?
Those are some dinosaur bones. You're walking them up.
Oh shoot!
Yeah.
Right there.
Nope.
Here. Oh, there we go. Thank you, Jesse. Yeah, shoot! Look at that. Nice. We do have some bits of dinosaur bone here. Look at that. Yeah, but that's. Let's see if we're back. Okay, we're back? Good. So the router is over there. I guess when I walk down here, the signal gets blocked for a minute. Because we don't have like direct line of sight. Yeah. But anyway, yeah. Yeah. So there's some bits of dinosaur bone down there, but yeah, this is the quarry. And Jesse's working on uncovering some more of this stuff right here. So, let's see here. Every bit of like sandstone block that you see up here was moved up here by this crew because every single one of these pieces has got important fossils in it. Like this bit of fossil leaf right here. Take a look at that. You can see the veins. This isn't one of the prettier ones. All the prettier ones are in that pile. But yeah, this is really important stuff for being able to figure out what this ancient environment was like. And La Vaca Loca, I'm thinking you could do ASMR dinosaur digging. There will be plenty of that later. I'm going to be streaming almost every day in the month of June, as often as I can. And today's not really a day for digging, for me at least. We're still kind of opening up these sites and seeing what we can get out of them. But there will be streams coming up where maybe I'll be doing some jacketing, doing some excavation, that kind of thing. But right now, we're just kind of settling in and seeing what's here. And what's here are gorgeous fossils. Like these. Here's this leaf again. Keep showing this because it is so pretty. Take a look at that. 73 million years old. And there it is. Just absolutely beautiful. Yeah. Really nice. Yeah. And Toner Rebellion. Is it true that crocodilians show some evidence that their Archosaurian ancestors were more warm-blooded and possibly even bipedal? Yeah, I mean, I'm not an expert on Pseudotsuchians, but we definitely can tell that there's like a big diversity of like body forms and probably physiologies as well, especially during the Triassic period. So yeah. And you have crocs doing some really cool things during the Mesozoic, like becoming marine. There were groups of crocodilian relatives, the Thalattosuchians, that evolved to be ocean-going animals. So over time, their arms and legs evolved into flippers, and they stopped laying eggs on land and actually started giving birth to live young in the water, which is super, super neat. Those are creatures that would have never come up onto land during their entire lives. They're just fully adapted to life in the ocean. And they're crocodilians, crocodilomorphs at least. Part of the croc family. Super cool stuff. Yeah, and we think they were probably close to being warm-blooded too. Just based on that environment. If you're living in the ocean, that sort of thing helps. Endothermy really helps out with that. Yeah. And let's see here. And Postosuchus, yeah, Postosuchus may very well have been bipedal, but probably would have been pretty slow walking around. Some of the 80% of the plants died off as well. A bunch of plants go extinct at the end of the Cretaceous. Yeah. And Nuggy Nabber says, how can you tell the age of a rock with a fossil inside? So we kind of get that through the context. Sometimes, if you have a rock with a fossil inside, you also get zircons in that. These little, almost like tiny little crystals that you could see under a microscope. And those have radioactive isotopes inside, and you can date those and figure out how long those radioactive isotopes have been decaying, which tells you how old the rock is, you know? How long has it been since that isotope got into there? But that's pretty rare. Oftentimes we have to find like an ash bed with zircons in it, or with radioactive isotopes, you know, outside of zircons. So it's really, really important not just to collect these, but also to study the surrounding rocks. To be able to map everything out, and then take what we call a section. So what we do is, oftentimes we'll we'll measure from bottom to top one of these hills here, and we'll very closely monitor how the rock is changing through there. So what exactly is going on in these ancient environments? You know, you have a sandstone here that's big and massive, and then you get a really friable kind of silty mudstone, or organic rich shale or something, and then you're measuring everything along. You put it onto a chart, and then you can work your way up to where you get an ash layer, where you can actually get a numeric date there, and then you can say, well, you know, these fossils are just below that ash layer, so that means that they're just older than, say, 73 million years. Does that make sense? Yeah. But yeah, and Volcano Doc says uranium, thorium, lead isotope systematics, usually in zircon and monozonite crystals, and lots of other ways too. Thank you, Volcano Doc. See, Volcano Doc, being an igneous geologist, knows way more about this than I do. So, thank you, Melissa. I appreciate that. Yeah. I almost got to work at a site last year where they'd found a bunch of zircons, and Jim Kirkland actually asked me if I could do a fundraiser to raise like $3,000 so that we can get a radiometric date. There's a laboratory that, you know, that's the going rate. That's what they charge to get a number. You know, it's $3,000. And then I guess he found another source of funding for it, so we didn't have to run the fundraiser. But we're excited for that. Be able to get some exact dates on that dinosaur bone bed out there in Utah. And surely zircons are igneous, so they would have to be weathered out of their rock before we can form sediment, says Saranlan. No, it doesn't really work like that. You can find them in the rock itself. And zircons are very, very hardy. They're really tough little crystals. Yeah. I think zircons are igneous in nature, though. Aren't they, Volcano Doc? They gotta be, right? Yeah, all those rare earth elements. And Ironbark says, we would have come through for sure on a fundraiser. I know you would have. No, everybody really came through with this field season. You know, getting all that gear off of the wish list. A bunch of that is being used here. today, right now, as we speak. So, yeah, right here. Some of the tools that Jesse is using right now are tools that you guys provided through the Amazon wish list. So right now, Jesse's removing some of the loose sediment around that slab. And then, yeah, Jesse, will you be cracking that open to see if there's plants inside?
I know there's plants inside.
Nice.
I can see some of them.
Very nice. Let me carefully walk over here. Oh, beautiful.
So, if you want to come just a
A little bit this way?
Yeah.
Thanks. Yeah.
Perfect.
Yeah. Nice. Yeah, look at that leaf right there. Holy cow.
There's one.
Nice. Nice. Look at that. Fossil leaf all the way from the Late Cretaceous. Check that out. You're just watching these be discovered in real time, Chad. This is pretty cool. Thank you, Jesse. Really neat. So you haven't really had to crack these open much in order to find them. They just kind of split along
Yeah.
along those lines.
As you get deeper, they start to be
That makes
more
sense, yeah.
shape, but these runs have been heavily eroded.
Yeah.
There's actually a fault that runs all along here,
Nice.
but this slab is lower and that slab is
That makes
lower.
sense, yeah. A little micro fault. Very cool. Very cool. Yeah.
Half of one there.
Nice. Yeah, look at that. In real time. Very cool. Very, very cool. How cool is that, Chad? Holy moly. This is what it's like. You know, this is such a cool site. We're actually really lucky that we've got so many beautiful plant fossils here. This is the best plant fossil site that we've got here in the Almond Formation so far, and chances are some of these are going to be new genera or new species. These are going to be new to science. Yeah. Very cool. Mind if I just stay here for a minute and
Yeah.
watch you work? 'Cause this is, you're just finding stuff left and right. Take a look at that, another leaf right there. See that vein running up it? Nice. And some of these are just going to crumble as soon as you take them out, right?
Yeah.
Like expose them to the elements, to the atmosphere, and they immediately start to degrade. Oh, this is awesome. Look at that.
So that's the other half
Yeah.
of that guy. Some sticks.
Yeah. Is that gypsum in there, all that white crusty stuff?
Yep.
Yeah. So that must have formed actually after these cracks formed.
Yeah.
You get all that those deposits forming in there. So Jesse's very carefully brushing that away. Get to the surface. And if we're lucky, maybe there's some remnants of leaves on there too. So it's, you know, slow going, gentle work.
No.
Nice. Over there. And that gypsum is a little frustrating, just obscuring the surface.
Yeah.
Very cool. Thank you so much, Jesse.
For sure.
Awesome. Let's walk in this direction so we don't step on anything. But every single one of these you see here on the surface has been collected from down here. And every single one of these has got plant pieces in it. That's why they're up here. That's why the crew placed them here. Yeah. Very cool. Yeah. So great to have everybody here. This is... Oh man, I'm so happy to be able to bring this to you. And happy to be here. Wouldn't be here without your support, so thank you everybody. And I'm glad I can give something back, you know? Yeah. Tim the Turtle says, hey yo, love to see this work being done. This is your site, Tim the Turtle. Because the first like good recognizable fossils we got out of here. This kind of was the heyday of the turtle. In North America, at the end of the Cretaceous period, we had the highest diversity of turtles in Earth history. It's something like 23 or 24 species of turtle from like the Hell Creek Formation. Nuts. And almost all of them make it across the KPG boundary. When that asteroid hits and wipes out like between 60 and 80% of life on Earth at the species level, almost all the turtles in the Hell Creek Formation survive. They make it across the boundary into the Cenozoic. It's only like the really big turtles that lived on land are the ones that seem to go extinct. Things like Basilemes. His name means king turtle. Right? Basilemes, king turtle? I think so. Anyway, yeah. And we've got some turtle fossils from here too, but so far nothing in situ, nothing like in the ground. Everything has been on the surface, eroded out. And so right now the crew is looking to see if they can find any turtle pieces. We want to find the turtle horizon in here in order to be able to get some good specimens. And how big was a king turtle? Basilemes got pretty big, I think. I want to say that sucker could be like 6 feet long, like 2 meters. Yeah, it was a big animal. We don't have anything like that from here yet, but yeah, potentially we've got some baenids, like Adocus, like Glenn was saying. Yeah, pretty neat. And Ms. Blue Sky says, do you actually excavate down or just the surface? Well, we create new surfaces in the excavation. That's the thing. It's not like we're tunneling into the side of the hill. We're creating these nice plains like this, like Cameron's doing here. Yeah, slow, painstaking work. Almost kind of like how an archaeologist works. You know, that's them's fighting words, but yeah. But yeah, it is slow and painstaking. You want a nice, clean surface like that. You want to do what some people call a planned excavation. You know, going from the top down so that you can see everything from above. Yeah.
It certainly helps when you're looking at a bed of disarticulated bones that are
Yeah,
so fragile.
For sure. Yeah, super cool. Everyone at home is really enjoying seeing this.
Great.
Yeah. I just discovered this channel, and this is so cool. Thank you. You're welcome, Wolf Daisy. Welcome to Paleontologizing. And do we ever encounter archaeological finds when looking for fossils? Hopefully we don't.
We found one at camp right when we arrived.
What was that?
It's a spear point, about 15 feet from my tent.
Really?
Yeah.
Oh,
It's
shoot.
isolated
I
now
wasn't
and
aware of
marked
that.
for the BLM,
Nice. Okay, cool.
so they know where it is.
Yeah.
Archaeological material can be trouble because that requires additional permitting. They have to get that
Yep.
out of the way first.
Yeah.
But, you know, paleontologists call archaeology overburden.
Exactly. It's all the crud that's on top that you got to dig through in order to get to the good stuff. Yeah, we were working a Leptoceratops bone bed in the Hell Creek when we found an arrowhead like 20 feet from the site. And very quietly put it back and didn't tell anybody because you don't want that kind of smoke, you know. Yeah. But yeah. And Toner Bellin says, careful, the creationists will consider that an admission that people hunted dinosaurs. Yeah.
Sadly.
Yeah. Any more turtle pieces or anything over here yet? It's painstaking work. Yeah. Well, cool. Thanks for letting me interrupt you for a bit.
Of course.
Yeah. Awesome. Yeah. Let me go drink some more water before I forget. Yeah. Definitely, yeah. Yeah, the dry mountain air combined with the heat and I was going to say the wind, but it's been very still today. And all the talking, yammering on, saps me of a lot of water, so I've got to make sure I stay hydrated. And Liara says, thanks for sharing this. It's fascinating. Thank you for being here, and thank you for the kind words. Welcome to Paleontologizing. Yeah. We are certainly doing some paleontologizing here. We got to make sure we do some hydrating also. That's empty. Let me fill this up. Here. Set you down for a second, chat. There you go. All right. Yeah, let's see if we've got any other questions in the chat. Miss Yvette says, let's see a lizard. I have seen a bunch of lizards, but they're generally too skittish for me to be able to catch on the camera. But there were some over there earlier, scurrying around on those rocks. Excuse me. How rude. And Ms. Blue Sky says, do you carry out all the water you drink? Or do you dig temporary wells? No, so what we do is, like most of the mammals that live in this area, we get our moisture from, chewing on the plants. No, I'm kidding. We carry the water out here. Yeah, and it's heavy. Water is not light. It's, that's some exercise. Yeah. At a certain point, you probably reach diminishing returns. Well, the water's so heavy that you sweat so much that you need to drink more water, and then... But thankfully, we haven't reached that point yet. Yeah. Anywho. And there's a question. From Zilla Birbo. Thank you, Claire, for reposting that. Sorry if this is a question that's been asked already, but if there's one find you'd really love to see this decade, what would it be? Oh, boy. That's a good question. One fossil find this decade that I'd really like to see. Oh, that breeze is nice. Ah, yeah. Oof. We haven't had much wind at all today, which has been a blessing and a curse. It's been way too windy the past few days, as it usually is in Wyoming. But today, we didn't have the crazy wind, but we did have crazy heat. So it's nice to have heat and a little bit of a breeze, I guess. But yeah, one find this decade. I would love to see some kind of an early dinosaur from the late Triassic, or even it'd be cool to even have one from like the end of the middle Triassic. That helps kind of elucidate what's going on at the origin of Dinosauria. That would be really cool to see. Yeah, and help figure out like what's going on with the base of Saurischia and Ornithischia, and are silosaurs actually are they Ornithischian dinosaurs, or are they non-dinosaur dinosauriforms? These are still mysteries right now, and it'd be really cool to have a new fossil that would help to clarify all that stuff. Yeah, because it's pretty mysterious, as many things are. When you're dealing with creatures that lived tens of millions of years ago, or hundreds of millions of years ago, the only window that we have into their existence, into their biology, into their phylogeny, everything else, it's through fossils, through the rock record, and this is hard-won information. I mean, you see how this is done here. This is actually like, this is almost luxurious the way that this is happening, like with all of these fossil leaves here. It might not look particularly comfortable out here. It's not, but it's like this is such a cool site with so many cool fossils in such a small area. We're really lucky. This is not normally how it goes. Like, we're very fortunate to be here. This is a world-class site, honestly. And yeah, I guess the point is there's a lot of hard work that goes into this. It's often harder work than what you're seeing right here. So, I don't know, next time you're reading a dinosaur book or watching a film that features dinosaurs or other extinct creatures, you know, that's only possible because, you know, people like us are out here doing this work in the first place. It's not always easy. Yeah. And were the crocodilians who gave live birth ovoviviparous? I think they were just straight up viviparous. I think it's difficult for animals that lay hard-shelled eggs to do ovovivipary, like the eggs hatching internally, especially if they're marine. Yeah. But vivipary is not a difficult thing to evolve for sauropsids, it seems. We've got multiple species of lizard and snake that can give birth to live young. You know, it's just no problem. So, it's cool. I was actually asking Takuya and Glenn about that last night, because they both work on marine reptiles and know a lot about them. Are there any marine reptile fossil groups, except for sea turtles, that laid eggs on land? You know, and they're like, no, I don't think so. They all gave birth to live young. The ichthyosaurs, the plesiosaurs, the mosasaurs, probably the thalattosaurs, maybe even, you know, placodonts and, you know, tanystrophiids and critters like that. They probably all gave birth to live young, which is really cool to think about. Yeah. Oh, and sorry, I'm way behind in chat. Catching up. Sunscreen. I put a bunch of sunscreen on before stream. Yeah. And Fossil Guy Tom says, are you guys looking forward to the new dinosaur life on our planet? I haven't even heard about that, but yeah, sounds cool. First one I thought was great. That's some excellent science outreach, you know? The world needs more of that. But yeah, and Balmer, we don't have money for drones, and in this kind of territory, like, those drones would get shot out of the sky, probably. There's a lot of landowners around here with guns who would not be happy about seeing a drone flying through the air. Yeah. Yeah. And Princess Kimmy says, I got my little one a zip-up vest that says Junior Paleontologist on it. She now runs around the house saying she's a dinosaur doctor. She's only 5. She sounds like me at age 5, although I didn't have a cool vest like that. That's awesome, Princess Kimmy. I don't know. When kids get interested in dinosaurs, a lot of cool things happen. You know, dinosaurs can be this wonderful kind of like gateway drug into science and into learning. You know, so many people first fell in love with learning because, you know, when they were a little kid, they were interested in dinosaurs. It just opened up this whole world to them. So, I don't know. As a dinosaur paleontologist, that makes me really proud that I can help contribute to discoveries that will inspire the next generation of scientists and engineers and doctors and philosophers and, you know, lawyers and anybody else who's in like a knowledge field like that, you know. It's cool to think that like the stuff that we're doing here is contributing to, you know, to people learning and to kids getting interested in the idea of knowledge. You know, it's pretty special. It's pretty special. Yeah. She loves Triceratops and science. I love Triceratops too. I've dug up a bunch of Triceratops over the years. It's one of my favorite dinosaurs. Yeah. But yeah. And Yakbone Battle Axe. What a name. Welcome. I want to know a more mundane question. What's that species of shrub that's all around there everywhere? Is it a hassle to camp and work around? So this is sagebrush. Yeah. Smell that, Chad. Smell that. Sagebrush. That's what gives this part of the world its, like, you know, distinctive smell. Yeah, I don't know the genus or species, but we call this sagebrush. There's probably several different varieties out here. But it's a kind of low-to-the-ground, scrubby, very, very hardy plant. It's evolved to tolerate both extreme cold and extreme heat, and extreme aridity. This is a really dry area, and these plants do super, super well here. This is kind of like the, you know, one of the cornerstones of the local ecology. There's all of this sagebrush around here. Yeah, lots of animals eat it. Lots of animals use it for shelter. They dig their burrows underneath, and those roots help keep the soil and the rock in place. But it can scratch up your legs if you walk through it while you're wearing shorts, you know. So I'd avoid that. Also, rattlesnakes like to hide in it sometimes. So, yeah. But it's, I don't know. I have a certain fondness for sagebrush, just because, you know, it's that distinct smell that reminds me of field work. This is what I was born to do, you know. And so, first got out of the car here on Friday when we got to camp, and just went, smell that sagebrush. Smells like adventure, like discovery. Smells like science, you know. And it can also be really useful in certain circumstances. In was that 2015, I think? My old crew chief, Denver Fowler, he just bought this old Ford truck, his first ever vehicle in Montana. And some sort of rodent probably crawled up into the air conditioning ducts and died. And so it just smelled terrible in there. So how did we deal with that? Grabbed some sagebrush and shoved it into the vents like a natural air freshener. And you know, it almost worked. Yeah. And sagebrush is called Artemisa in Spanish. So different sound. Interesting gravity. I like that. Artemisa. Ah, bonita. Yeah. Sup, Paleontologizing in chat. You're outstanding in your field. I am outstanding in the field. We are out here in the field. Out here in western Wyoming. And it's great to have you here. Thanks for joining us. Yeah. Probably Artemisia tridentata. Interesting, bozocentric. Thank you. I really ought to iNaturalist this. I don't think I've ever done that. Yeah. Oh, and Lenina, thank you for reposting from Lordy. Sorry I missed you, Lordy. Lordy says, hi, Danny. Hi, friends. I can't stick around, but wanted to say hi. Appreciate that, Lordy. I hope you're doing well. Lordy's out. I forget what she's doing today, but yeah. Yeah. Anywho. Good stuff. Sage advice. There you go, Anded. Yeah. Excellent. And use iNaturalist too? It's wonderful, Miss Caprikel. It's wonderful. Yeah. Speaking of wonderful, let me drink some wonderful water here before I get wonderfully dehydrated. This is dry country out here. Gotta make sure you're always drinking water, especially if you're just yapping on and on and on about science on stream. All right. Oh, we got another addition there. Nice. Jesse just put this down right here. Got another piece of a leaf. Beautiful. So many gorgeous and scientifically important fossils here. Look at that leaf. Exquisite. Yeah. Have you got a favorite specimen so far, Jesse?
We wrapped it up already.
You wrapped it up earlier? Nice. So the most beautiful and important ones we make sure to bring back to camp immediately. But yeah, that's a real looker right there. Nice. Yeah. Very cool.
First see tube turtle here.
Hoo 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 hoo! We've got turtles in the turtle lair.
Turtles in the turtle lair.
Yeah, it's turtle time, chat. Let's go take a look. Am I okay to step over here?
Yes.
All right. Hopefully we don't lose signal. There's routers right there. All right.
Oh, Pick discovered part of him.
Uh-huh.
So we,
Discovery mark,
yeah, a couple of edges come off, but they're here and in here.
Nice.
And then-
Decent chunk.
Large piece of looks to be a plastron to me,
Nice.
which is the shell at the bottom of the
Mhm.
turtle. So yeah, so we anticipated this is where the float turtle was coming from layer, and
Uh-huh.
now I think we've confirmed that.
Awesome.
Maybe there's a good deal of this guy. We'll see.
Fantastic. That is really exciting. Thanks for calling me over.
Yeah, yeah, no problem.
Cool. Oh, there's a reason this site's called Turtle Hill. It's because,
Finally.
yeah, it's finally living up to its name this year. Yeah. Awesome. Very, very cool.
Who's got the butte bar there?
Spoke you up.
Thank you.
Yeah. Oh, maybe you can explain this process too with our PVA.
Yeah, so right. So this is an archival consolidant,
Mm-hmm.
essentially glue. We want to soak the bone as much as we can because it's clearly can see it's fractured and not just from the pick.
Yeah.
And it's very, very brittle, very delicate. So we want to harden that in place to the degree that we can
Yeah.
before we take it on out.
Nice.
It's a larger block.
Yeah. So everybody home, this is kind of polyvinyl acetate glue. This one's Bootvar or is it?
It's beautiful. It's B76 or 2. I'm not sure which unit
Nice.
you're using.
Yeah.
Yeah.
Yeah. So basically, this is for everybody at home. It's like a kind of plastic that you dissolve in acetone. So the acetone, it's like nail polish remover. That dissolves the plastic and it makes everything really thin. You know, the opposite of viscous. Thin is the opposite of viscous in this context, right? Is
Yeah.
that the right
Yeah,
word?
yeah.
Thin.
That's absolutely right.
Okay,
We want-
yeah.
If it's too thick, it just coats the outside. We want it to-
Exactly. Yeah.
We want it to act as a penetrant, get
Mhm.
inside the bone.
So the thinner it is, the more it can soak in, and it kind of draws the plastic inside, and then the acetone evaporates away, as nail polish remover does, and it leaves the plastic in the interior to kind of harden it from within. So, yeah, neat stuff. Thank you, Glenn.
You're welcome.
Yeah.
It is exciting.
Finally, we got some turtles. This is great. Yeah. And Bob, can I ask you what you're working on?
Glenn gave me the little pieces from around where he found the turtle, and I'm looking through these for small pieces of turtle.
Nice.
So I'm uncertain about if I don't think I found any, but I'm asking Glenn about a couple that I'm not sure about.
Yeah. So yeah, you'll see some of the like plastic tools that we use here, chat, like these scoops. These are, I guess, like plastic feed scoops.
Yeah, the
use.
grain
Yeah.
scoops, yeah.
Grain scoops, yeah, for like an agricultural setting.
Yep.
But these are standard equipment for field paleontologists.
You won't see a single tool developed for paleontology on the site. It's
Yep.
all been adapted from something
Yep.
else.
No, there's not enough of us in the world for anybody to manufacture tools for us, except for maybe Estwing. They've done a few,
We've
but
done a good job.
Yeah.
Recent years,
yeah. But yeah, you know, we got to kind of scavenge what we can find and repurpose it for our paleontological purposes. But so scoops like that, when we're working through some of this matrix, pick up bits like when we're doing some digging. It's like all the pieces that we pull off, all these pieces of rock, you put them in the scoop, and that way, like you know where they are. If you see like, oh shoot, there's a bone here and it's missing a chunk, where did it go? You look through your scoop, and hopefully it's still there. That's why we do that. So, yeah, I hope that makes sense, Jeff. Yeah. I think maybe we got another raid. Let's take a look. Stand up for a second. Let's see. Marin Fall says things you didn't think you'd learn at 33 years old. Well, I'm glad you're here and I'm glad you're learning stuff. I hope you're having fun. Yeah. And maybe there could be a custom-made tool if it were 3D printed at home. Certainly. If I had a mirror, I would show you, but the thing holding the camera and the microphone together right now, I 3D printed at home. But yeah, 3D printed parts are often not going to be durable enough to be used for actual excavations or anything like that. There's a lot of metal tools. Those scoops they're hard enough plastic that they last a number of years, but eventually you leave them out in the sun and they crack and stuff. And for new people, what have we found so far? Oh, Dinosaur Dave? Yeah. Welcome back, Dinosaur Dave. We're here at a site called Turtle Hill out in western Wyoming in the Late Cretaceous Almond Formation. And we've got bits of turtle over there. We've got bits of fishes. We've got some beautiful clams. I'll show you those again. And we've got all of these gorgeous plant fossils. Lots and lots and lots of fossil leaves. Let's take a brief look at those and then I'll show you the clams. And I like turtles too, Landon History Buff. Turtles are interesting creatures, and they were super abundant at this time and place. Lots and lots of species of turtle. These are all pieces of rock that, Jesse, you probably put most of these up here, right?
Yeah.
Yeah. So you can see all of these different pieces, all with bits of fossil plant in them. And this is really important stuff for figuring out what this ancient environment was like. Would you care to show us those, actually? I'll put you on the spot. But, nice. Look at that leaf right there. Holy cow, that's beautiful. Thank you, Jesse. Holy moly. Nice stuff. Yeah. Sorry to keep asking you to do that, but we've got people trickling in and out, and it's, a live broadcast.
I find them as fast as they come.
Exactly, yeah. Yeah. And any crabs or crustaceans? Love Shelly boys? So we've got some Shelly boys that aren't crustaceans here. Let me show you. We've got a bunch of fossil clams here, and some fossil snails. Like this guy. There's a Shelly fella for you. Yeah. Freshwater snail and freshwater clams. Yes, very gentle with that. There you go. 73 million years old. Take a look. Pretty awesome. This tells us that this was like an environment with some flowing water at the time. The sandstone tells us that, but the clams kind of give us a better picture of like what kind of a fluvial environment is this. Fluvial or maybe estuarine, like a delta where the river meets the sea, because that's the thing. At this time, 73 million years ago, oh, and hang on, did we get a raid? No, just more people coming in of their own volition. Very cool. Yeah, and micropaleontology is a science, absolutely. You look under the microscope at microscopic fossils. Yeah. Have you, as a dinosaur-focused paleontologist, ever uncovered a microfossil? Yes and no. So, as a vertebrate paleontologist, what I consider a microfossil will be very different from what, like, an actual micropaleontologist calls a microfossil. So, microfossils that we find out here in the field are just little fossils, like, you can see them with the naked eye, but they'll be like fish scales, salamander vertebrae, maybe if you're lucky, little dinosaur teeth, stuff like that. And anything from a mammal in the Late Cretaceous of North America will be a microfossil. Mammal jaws, mammal teeth, mammal bones. Those are what we call microfossils. But paleontologists who study fossil plankton, fossil foraminifera, fossil diatoms, they're actually looking at that stuff under the microscope. So those are true microfossils, not microfossils like in our sense of the word out here. Does that make sense? Yeah. Drink some water and let's talk about where the ocean was back here at this particular time and place. There we are. So I've showed this pretty much every day on stream so far during this field work, but it warrants showing again. Yeah, first, look at this landscape right now. This is western Wyoming, near the town of Green River, as it is today. We're probably about 7,000, maybe 7,500 feet in elevation here, up here on this hill. It is high desert country. Very dry, very high. This is not what this area looked like 70 million years ago. Back then, this is what North America looked like, more or less. Sea levels were much, much higher. The Rocky Mountains are just starting to come up right here. And then you've got what we call the Western Interior Sea, a shallow, tropical, almost Caribbean or Mediterranean-like sea in here in the center of North America. This is the state of Wyoming, right here. And we are currently right there. So during the Late Cretaceous, the seaway expanded and contracted. It's just continuously moving around as sea levels rise and fall. And then mountain building pushes up the land, and that changes the coastline and stuff. So 73 million years ago, at the time these rocks were being laid down, the seaway had advanced, it had expanded, sea levels rose. We're right here on the beach here. And so as a result, this environment would have been this low-lying, swampy plain. Like I've said before, think about like a Louisiana bayou, think about the Mississippi Delta. Think about that whole part of the U.S. today, where you've got rivers, swamps, oxbow lakes, and massive floodplains. Pretty wet environment, pretty warm. Like in Mississippi Delta today, you would have had various kinds of trees like cypress and stuff like that. Probably dogwoods and laurels. I think they live in Louisiana today, don't they? We find them here in this environment. And you also had crocodilians. Not quite alligators per se, but alligator-like crocodiliforms lived at this time, and lots of turtles, and then lots of kind of, what you might think of as swamp fishes, things like bowfin, things like gar, probably paddlefish and sturgeon are living in this kind of environment too. And of course, clams. Let's take a look at some of those that we've got here. Yeah. Here's some of our more impressive unionid clam specimens right here in situ. In situ means like where, in the ground, in the rock, in place. Here we go. Take a look at these. Beautiful. Just this lovely pavement here. So we're hoping to collect this, and scientists here from Cincinnati are going to be taking it back to the museum and maybe putting it on display after cleaning it a little bit. Got some dirt on here and some lichen. They might want to clear that off and kind of make it look a little bit more spiffy. But check that out. Just smoking gun evidence of this ancient environment. These shells right here, these clams, show what this ancient ecosystem was. Yeah. Very cool. Very cool. And let's see. That one guy says, wild how millions and millions of years ago the vegetation would have been very similar to today's. Equal environments, yet the creatures are so different. Well, if you were to talk to a plant person, they'd be like, well, the plants are actually very different too. I'm not a plant guy, so, I am probably de-emphasizing how different the plants were, but the flora would have been different in a lot of ways. No grasses at the time. There were fewer flowering plants than today, although we do have a lot of flowering plants here. They're starting to take over in the Late Cretaceous. Yeah. But yeah, imagine that, a world without grasses. That's the world the dinosaurs lived in. Instead of grasses, you had things like ferns and horsetails, spike mosses and club mosses, stuff like that. Kind of low to the ground, gymnosperm plants, and yeah. Let's see. Scroll down. And Weedabixlick says, still blows my mind that something could lay undisturbed for so long. Yeah, I guess, in a way. These are, you could say that they're undisturbed, but also they've been very much disturbed in the sense that they are now 7,000 feet higher in the air than they used to be. This is no longer sea level. And so And the fact that they're like being exposed on the surface here too means that they are kind of disturbed in a way. Yeah, they've been entombed in the rock for that long, certainly. But like the changes in the earth itself, the uplifting of the Rocky Mountains, and this increasing elevation here in this part of the world has just brought these to the surface where they used to be way, way, way down deep below it. It's pretty cool. Pretty cool to think about. Yeah. But yeah, Volcano Doc is absolutely correct, though. It is hard to become a fossil. Oh yeah. Think about this environment here out in Wyoming today. You look out across this landscape, and we are way up high in the air, 7,000 feet. There's a ton of erosion going on here. So this is now an erosional environment. Erosional versus depositional. I'm sure this is an oversimplification, but this is how we often think of it as paleontologists, is that you've got two different kinds of environments, sedimentologically speaking. You've got erosional environments, where the rock is being actively destroyed, it's being weathered away, and new stuff is getting exposed. That's erosional. There's a lot of erosion happening. And then there's depositional environment, where you have deposition, sediment being deposited, stuff getting buried, the layers building up and building up. In erosional environments like this, where you've got so much erosion that like plants can barely hold on, and there's no real soil forming, because this is such a dry region, and there's so much wind and snow and just weathering going on, that it's erosional. Stuff's getting worn away. This is not a place to become a fossil. This is an erosional environment. All of these plants and animals that live here, very, very, very few of them are ever going to get a chance to become fossils. Pretty much none of them, probably. In order to become a fossil, you want to get yourself into a depositional environment, like the Louisiana Bayou. Low-lying, low elevation, like a nice basin where you've got sediment that's coming down rivers, and then it's, burying stuff in it. You've got silt building up and building up. That's the best place to become a fossil. That's a nice way to get yourself buried. And then hopefully it continues to be a depositional environment for a long time. And then, if you're really lucky, just at the right moment, something changes. Maybe there's like mountains build up near you, and it goes from a depositional environment, low down a basin, into an erosional environment. Stuff builds up, and then it starts weathering away. And then maybe a paleontologist will find your fossils. That's what happened with all of these critters here, all of these plants. That turtle, those fishes, those clams, and the dinosaurs that we're finding, they got really, really lucky. They happened to live at a time and a place where they were in a depositional environment, and then conditions changed, and after they'd already been buried and fossilized, that area turned into an erosional environment. Stuff was being eroded and allowed us to find them. So, a zillion things have to go exactly right, in order to become a fossil and then end up in a spot where you can get found. So, every single one of these fossils that we find is almost a small miracle, But that's the thing, is that even unlikely events, given enough time, they become inevitable, Over tens of millions of years, even very, very unlikely events like fossilization, they happen again and again and again because there's just so much time there. It all builds up, Yeah. And that's when they've got hard parts. Exactly, Volcano Doc, yeah. We're not finding very many slug fossils out here, We do have some snails, like I showed you earlier, but no fossil slugs, because they don't have hard parts that fossilize easily. Slugs are squishy and they decompose readily. And they're a good example of like a critter that I'm guessing the fossil record of slugs is pretty poor, because there's not a lot to fossilize there. Yeah, you would have to have extremely specific conditions in order to preserve a slug as a fossil. It doesn't happen very often. When you have hard parts, it's like it's a nice insurance policy. It's like you're much more likely to become a fossil if you've got hard parts that are easily fossilizable. And Landon History Buff, thank you, Claire Burr, for reposting this. Unless you haven't found it yet, what's the thing you've always wanted to find? Oh man, there's a lot of things I want to find. I'd love to find a leptoceratopsid in this environment, or an ornithomimosaur, or a tyrannosaur, or a dromaeosaur, or a pachycephalosaur, or an ankylosaur. There's so many things I'd love to find here. Yeah. I don't know, the list goes on and on. It's hard to choose just one thing, you know? But what I am going to choose is to drink some more water right now before I forget. And put some more lip balm on. Yeah, hydrate before you become a fossil. Will do, Seven Crow. Thanks. Here, you go keep watch while I take a drink here, okay? Okay. Yeah. And I found slug plates in La Brea and banana slug plates in Orange County. So slugs have hard parts too? I guess they probably do for chewing, don't they? They've got to have something for rasping away at that vegetative material that they eat. So okay, I take it back. We do have slug fossils. Probably in some degree of abundance. Cool. Thank you. There. Thank you, very much there, Dr. Hubs. Many slugs have internal plates, the remnants of shells. Nice. Yeah. Yeah. And slugs hard to fossilize, leaves everywhere. Nature is wild. Yeah, but also I'm sure there are bite marks from slugs on leaves. A big part of the fossil history of insects actually comes from bite marks on fossil plants. So like the distinctive kind of patterns that different species of insect make when they're chewing on leaves, those are identifiable. You could say like, oh, well, this is this particular kind of beetle, this is a particular kind of ant, that kind of thing, based on the bite marks that they leave. And so you find those bite marks on plants from the Cretaceous or the Jurassic, and you can go, oh, well, this group of insects seems to have been around already, even if you don't find their body fossils, you know? And the wireless god says, do you ever dream about fossils or dinosaurs? Oh yeah, all the time. Yeah, apparently I used to talk in my sleep, and my girlfriend in college, one time she told me that I was talking about ichthyosaurs in my sleep for some reason. I don't remember that dream, but that's what she said. And very funny Twitcher. No, that's back in camp. It's just water out here. Yeah. And slugs could also get stuck in amber too and be preserved that way. Maybe. Yeah. I don't know if we have any slugs from amber. We probably do. I don't know enough about that kind of thing. Yeah. But yeah, let's see. Slugs and snails have many teeth called radula. There you go, Hogan. Yeah, I'd forgotten about that. I gotta come up with a better example. I guess I could say fossil worms, because they don't tend to have hard parts for the most part, like earthworms. But then we do have fossils of them too, trace fossils. So fossils aren't just the parts of extinct organisms. They can also be other bits of evidence that they leave behind. It can be things like footprints or fossil nests. It could be stuff like burrows or worm castings. Those are other good examples of trace fossils, and we do get those. Yeah, for certain. And there are paleontologists who just, that's what they work on, is trace fossils. People like Tony Martin at Emory University down in Georgia. He's an expert on trace fossils, a paleoichnologist. Ichnology is the study of traces. And, yeah, it's important and interesting stuff. It's not all just bones and shells, teeth and hard parts. The study of fossils is wide and varied. And Link for Real says, I love this stream. I wish I could be out in Wyoming. It's pretty cool out here. Oh, it's very warm today. but it's nice being here for certain. I'm going to be out here for the whole month of June and streaming to you as often as I can, almost every day. So I hope you stick around. We'll be doing a lot more of this. And yeah, not to be confused with ichthyology, the study of fishes. Non-tetrapod fishes, I should say. But yeah, ichnology, I-C-H-N-O-L-O-G-Y, ichnology. Yeah. And Hogan says, I know a paleontologist that collects coprolites, and another one that specializes in footprints. There you go, Hogan, yeah. Yeah. And I'm going to be out in Utah as well, Link for Real, from mid-July to mid-August. I'll be streaming from near Moab, Utah. That's going to be a ton of fun. And science sure has many large words. Okay to play? I suppose it does. Yeah. That's the thing. Jargon can be both a blessing and a curse in science. As scientists, we're trying to communicate ideas to one another. We try to use really precise language. And oftentimes that requires very specific terminology. And many of it is like Latin or Greek-based. Yeah, precision in our language is important in science. And so that lends itself to some long words sometimes. But you study this stuff for long enough, even if you're just reading about it in, popular science books and stuff, you start to learn that lingo. It's almost kind of like learning a second language through osmosis. And it's cool to be able to make connections with different concepts because they've got similar root words and stuff like that. I never took any classes in Latin or Greek, but there are a lot of Latin and Greek roots that I've learned just, by means of, studying fossils and reading through the literature and all that stuff, conversing with colleagues. It's neat. It gives you how would I put it? A different kind of avenue into learning about stuff, and you can make connections in everyday life that you wouldn't otherwise be able to make, because certain concepts like, oh, I know that word, that means this, and that's from part of this dinosaur name, for instance. Yeah. Let's see. And Volcano Doc says, and expressing that in regular English can actually be quite hard. It can be, yeah. Some of the jargon words have meanings behind them, so they're easier to use. Absolutely. Sometimes using a jargon word actually simplifies things significantly, because you don't have to have a paragraph-long description of what you're talking about. You can just say, oh, a unionid clam, or a Lambeosaurine hadrosaur, instead of saying, oh, those duckbill plant-eating dinosaurs, many of which had large, showy crests on their heads. They inhabited North America during the Late Cretaceous period. No, you just say, oh, Lambeosaurine. And, everybody who knows that word knows what you're talking about. It's a lot shorter. So, yeah, absolutely. And Princess Kimmy, you have a great rest of your day. Yeah, and you get some good rest. Thanks for being here. Oh, and Lenina, thank you for reposting that from I'm Big Daddy's Dad. Big Granddad, apparently. Do we have any idea of the lifespan of a dinosaur? Great question. Great question, I'm Big Daddy's Dad. We're starting to figure that out. That's been a mystery for a long time. It's actually really, really important to understand for dinosaur paleobiology. How old could dinosaurs get? How old were certain dinosaur specimens when they died? That has tremendous bearing on dinosaur diversity. For instance, there's a lot of different dinosaur species and genera that have been named, where it's like, oh, well, this one looks pretty similar to that other one. Think about like Dracorex and Stygimoloch and Pachycephalosaurus. We thought they were all closely related, but they must have been different species or different genera. And then you actually start studying them in detail and you realize, oh, one of them is young, one of them is kind of like intermediate in age, and one of them is an adult. And it's all the same animal. They just change a lot as they grow and mature. So it's really important to understand if a dinosaur specimen was young or old, because then you can hopefully figure out, is it actually a new species or is it not? You do that by cutting the bones open and looking at the growth rings inside. That's your best, most foolproof method of figuring out let's say the maturity level of a given dinosaur specimen, how old it was when it died. And we've only really been doing this in earnest for a couple decades, I'd say. It's becoming more and more common. A lot of folks are actually really resistant to doing that because they don't want to cut open their dinosaur bones to count the growth rings. But, if you're going to make an omelet, you got to break a few eggs. Glue is cheap. We collect these specimens to gather data on them. Sometimes you got to cut them open. It's important. So trying to figure out, what is the maximum age for a dinosaur? What is the oldest dinosaur that we have? The one that had the most years under its belt before it died? We're just kind of starting to figure that out. I think some of the oldest dinosaurs we have right now are in their late 40s. There is a big theropod dinosaur from Argentina. I think it's Meraxes gigas. It was published a couple years ago. And I think that one was thought to be about 47 years old when it died. And that might be the very most mature dinosaur we have so far, where we've actually cut the bone open and counted the growth rings. It seems like most dinosaurs lived fast and died young, and most dinosaurs probably died long, long, long before they reached full somatic maturity, before they actually stopped growing. We do have a good sense that most dinosaurs, if not all of them, probably had a maximum size. It's not like they're growing continuously throughout their lives. They do seem to actually have a skeletally mature, I'm no longer really growing kind of stage, but that could be overturned with more fossil finds. We don't know. A lot of this stuff is we're still kind of figuring it out. And there you go, Hogan. Yeah, no, 21. Yeah. And who claims trilobites are dinosaur age? No, trilobites are from long before the dinosaurs. The very last of the trilobites seemed to die out at the end of the Permian period. About 250 million years ago. And 252 million years ago, I think. And the first dinosaurs that we have are about 235 million years ago. Although they probably evolved a little bit before then. So yeah. So there's a chunk of time in between the trilobites and the dinosaurs. They did not overlap at all. Yeah. And there you go, Paleo Ken. Yes, I agree. Wait, which one was named after Song of Ice? That's Game of Thrones, right? There was a dinosaur named after Game of Thrones? What was that? Wasn't Meraxes, was it? Is that where that name comes from? Let's see. And Squall Advisor says, what do you think would help raise interest and awareness in paleontology, leading to more or better funding? That's a great question. I'm hoping that things like this can help do that. Live streams like this. That's the whole reason why I'm doing that. But, other stuff that's helped in the past has been Jurassic Park had a huge influence on the history of dinosaur paleontology. I was talking with Jim Kirkland about this, and apparently there were, not very many dinosaur paleontologists in the world before that film came out. Something like 40 in the entire world, 40 dinosaur paleontologists. And now there's, I don't know how many. I'd say at least 200 or 300. So Jurassic Park helped to kind of inflame this enthusiasm in the general public about dinosaurs. And that lent itself to more scientific funding. More money for museums, more money for, new professorships at universities. Suddenly, kids wanted to take dinosaur classes when they went to college. And so paleontologists could make a living, teaching at universities and stuff like that. Jurassic Park had a huge influence. So stuff like that does help. And I'm hoping to present on some stuff like this at the Society of Vertebrate Paleontology meeting this October in Minneapolis. I'm going to be gathering some data on like the pace of dinosaur discovery and how does that correlate with funding, availability of funding. So, yeah. And Imagination 2 Forms is kind of like Top Gun. A lot of people wanted to become pilots after that. Bingo, same idea. Yeah. There were probably a lot of people who wanted to go into storm chasing after Twister came out. Hollywood's got a big influence on stuff like this. It's nothing to sneeze at. Yeah. And that one guy, I have met Bob Bacher. Yeah. And other heavyweights in the field, sure. I used to work for Jack Horner. We're here with Glenn Storrs right now. He's a heavyweight in the field. He's a big name in dinosaur paleontology. And he's right there.
Put me on the spot.
Oh, yeah. Thanks, Glenn. So, yeah. It's a pretty small field, There's not that many of us. And so you kind of get to know everybody, especially if you go to conferences, But yeah. Yeah. And you wrote a book report on Bob Bacher's Raptor Red a few years in a row. I may have done the same thing when I was in middle school. And shoot, Glenn is a student of John Ostrom. Ken, absolutely. Like, one of the biggest names in dinosaur science ever. It's funny, the connections that are there. It really is a small world. And I'm really lucky to be part of it. Yeah. And when's the next conference? In October. Yeah, it's usually every October. This year it's in Minneapolis, so I'll be presenting there if my abstracts get accepted. It's always a chance they won't be. And Spinonicus Art says, are you only counting the active and formally educated dinosaur paleontologists, or also volunteers in the field of research? I guess my definition there is people who publish in the field. I would call if you publish on dinosaurs, you study dinosaurs, you're a dinosaur paleontologist. I guess that's kind of my definition there. Yeah. Yeah, and Matt LaMotta is a huge name, and he'll be here in about 2 weeks. Yeah, excited about that. Now, how hard is it to make a decent living as a paleontologist? Oh boy, it depends on what you mean by decent living, but it's often not easy. I could tell you right now, I make my living through doing live streams like this. This is how I get paid, through Twitch. And, I make enough to survive on. I'm doing okay, for sure. This is way more money than I've ever made in an official capacity as a paleontologist. When I've been hired to do fieldwork or research, it's been way less than, $10 an hour was the most I was making doing that. I make a little bit more than that doing this. So thank you to everybody who makes that possible. Yeah. And do you feel like everyone wants to argue with each other at these conferences? No, not really, Scrooge McKirk. Great name. There's a little bit of argument, for sure, but we tend to be pretty cordial. We're scientists. We're all on the same team at the end of the day. We all want to figure out what's true. And that tends to keep us from being too acrimonious, for the most part. You get certain personalities that are a bit more abrasive, but for the most part, we're cordial with each other. We're all interested in fossils, and there's a certain camaraderie that comes with that. And thank you, Miss Capri Kell, for all those gift subs. Holy cow. 10 of them right there. Thank you, Miss Capri. I really appreciate that. Thank you for your support. Helping me make a more decent living there. Thank you for that. I appreciate it. And I'm sure those 10 recipients appreciate not having to watch any ads for the next 30 days. Thank you for that. Yeah. It has been claimed in a paper is like the wrestling ring bell thing. Please, thanks. Yes. And Ken says I'm working on being less abrasive. Ken, you're wonderful. Don't even say that. Oh shoot, it's 5:30 right now. I got to start packing this up. Got to put my gear away and start getting ready to go back to the vehicles. And Kazoo Speed says, "Wow, a dinosaur dig stream? How cool! Thanks. I'm wrapping this one up right now, but I'll be doing this as often as I can, as close to every day in the month of." Make sure you follow if you want to see more of this, and hopefully we'll be streaming again tomorrow from a different site, probably. Let's say good. And that's gotta be a good one right there, the chest. Yeah, let's go ahead and wrap this up, everybody. Oh, and holy cow, we're just getting a raid. I appreciate that very much, Generator Fragdi. Holy moly! All right, I got to keep going for another few minutes. Welcome, welcome, Generator Fragdi and Raiders. I was getting ready to wrap things up here, but I'll stick around for you. Thank you for the raid, and welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm streaming to you from wild and beautiful western Wyoming right now, where we're digging up dinosaurs and a bunch of other critters at this site. We've got organisms galore. From fossil clams over here. Yeah. Look at all of these beautiful freshwater clams. Assorted varieties. Here's a lovely freshwater snail. Right here. 73 million years old. We've got all of these beautiful fossil leaves that Jesse's been putting up here after finding them. He's labeling a specimen right there. It's got to be a good one because it's all wrapped up. But some of these are just gorgeous. Look at that. Yeah. And yeah, we've got turtle pieces, fish pieces, the teeth of rays, like stingrays, but ones that lived in freshwater, and even some dinosaur bones from this site too.
Just found a new bowfin tooth.
A new bowfin tooth, nice.
Yeah,
How big?
About an inch and a half.
Holy
maybe.
cow.
A little smaller than Glenn's.
That is nuts. Still, that's...
Yeah, it's beautiful. It has like the nice green coloration at the end.
Yeah, bowfin are really cool fish. They're still around today, but this is probably a different genus, probably Melvius, we were saying.
Yeah, that's what's been going
Yeah,
on.
and that is enormous. That's so much bigger than they get today. Awesome. Cool. It's
exciting.
already wrapped
Cool
up, right?
stuff. Yeah, everything's covered up.
Yeah, shoot. Well, maybe next time we'll see one, because you're finding more of them. That's really exciting.
Yeah.
Yeah, good chance that we'll be able to find more in the future. But I really do need to wrap this up, everybody, because I got to get my gear packed up, and we got to get over there so we can go back to the vehicles. But thank you, everybody, for a wonderful stream. Let's see who else is live on Twitch at the moment, and we will go pay them a visit. We'll go do a raid, try and make somebody's day here. Who else is on? Let's see. Granny Uo's Lab, Turtles and Chill, Sinat Bush, California Birds. Let's see. Let us go say hello to... You know, maybe let's go raid, I don't know. Alveus Sanctuary. Animal Sanctuary, that'll be cool. Come on now. There we go. Yeah, excellent. Cool. Well, we're going to get ready to do that. Thank you, everybody, for another wonderful stream. I hope you learned something today. I hope you had a good time. Thank you again to Glenn and to Jesse. Cameron, thank you. Yeah, and I hope to see you tomorrow, everybody. You take care of yourselves, and let's go right into Alveus Sanctuary. I'll see you there.